Somewhere out there right now, someone might be watching you. Not a government, not a company, not a satellite in low Earth orbit. Something much stranger. Something that has watched your entire species climb down from trees, discover fire, build pyramids, split atoms, and launch rockets into the empty space beyond Earth. Something that has never once said hello. This is the zoo hypothesis, and it might explain why the universe seems completely empty. But before we begin, do not forget to subscribe, and if you truly enjoy these videos, please leave a like. Let us begin. Somewhere out there right now, someone might be watching you. Not a government, not a company, not a satellite in low Earth orbit, something far stranger. Something that has watched your entire species climb down from trees, discover fire, build pyramids, split atoms, and launch rockets into the empty space beyond Earth. Something that has never once said hello. This is the story of an idea that began with a simple question and grew into one of the most haunting possibilities in all of science. An idea that suggests we are not alone in the universe. We have never been alone. And the reason we have never found proof of alien life is not because they do not exist. It is because they do not want to be found. They are watching, waiting, studying us like specimens in a cosmic terrarium. And they have rules about what happens next. Over the next 2 hours, we will travel from a physicist's lunch table in 1950 to radio telescopes scanning the sky today. We will meet the scientists who dared to ask why the universe is so quiet. We will explore the ancient cosmos and discover why time itself suggests we should have been visited 1 billion times already. We will examine the evidence hiding in plain sight, the strange encounters governments can no longer explain, and the mathematical certainty that something is deeply wrong with our understanding of reality. And we will face a possibility that changes everything. What if humanity is not searching for extraterrestrial intelligence? What if extraterrestrial intelligence found us long ago and simply chose to watch? Welcome to the Zoo Hypothesis. Chapter 1. The question that haunts the universe. Summer 1950, Los Alamos, New Mexico. The desert heat shimmers above the same sands where 5 years earlier, the first atomic bomb turned night into day. The scientists who unlocked that terrible power still work here, studying the deepest secrets of matter and energy. Among them walks a man whose mind holds many ideas. Enrico Fermi, Italian-born Nobel Prize winner, one of the creators of the atomic age. His co-workers call him the Pope because when Fermi speaks about physics, there is no higher authority. He built the first nuclear reactor beneath a football stadium in Chicago. He helped create the bomb that ended the war. Now, in the uneasy peace of 1950, he turns his powerful mind toward lighter questions during lunch breaks with other physicists. On this particular day, the conversation drifts to flying saucers. The newspapers are full of them. Since 1947, when pilot Kenneth Arnold reported 9 shining objects racing past Mount Rainier at impossible speeds, America has been gripped by UFO fever. Sightings increase. The Air Force investigates. Theories spread about visitors from other worlds. Fermi's co-workers laugh about the reports. Science fiction, most of them think. Little green men in silver ships. Nonsense, but Fermi is quiet. His mind is working. He is not thinking about whether the latest sighting in Nebraska was a weather balloon or a trick. He is thinking about something much bigger. He is doing the math. And then, cutting through the noise of the cafeteria, Fermi asks a question that will echo through the next 75 years of human thought. Where is everybody? The table falls silent. Everyone understands right away what he means. Not where are the flying saucers, but where, in a universe this huge, is everyone. Consider the numbers. Our galaxy, the Milky Way, contains somewhere between 100 billion and 400 billion stars. Our universe contains at least 2 trillion galaxies. The numbers are so large they almost stop making sense. There are more stars than grains of sand on every beach on Earth. More galaxies than seconds since the universe began. And the universe is old, 13.8 billion years old. Our sun is a middle-aged star, about 4.5 billion years into its life. But many stars formed billions of years before ours. Their planets had billions of years more to develop life. Billions of years more for that life to grow intelligence. Billions of years more for that intelligence to build technology. If intelligent life appeared on even a tiny fraction of those older worlds, they would have had an unbelievable head start. A civilization that developed technology just 1 million years before us, a tiny blink in cosmic time, would be as hard for us to understand as we are to ants. A civilization 1 billion years ahead would be so far beyond us that the word alien barely fits. And here is the key. Even with the slow rockets we have today, a determined species could spread across the entire galaxy in just a few million years, moving from star to star, system to system, filling every livable world. Even if they traveled at only 1/10 the speed of light, even if they stopped to build societies at every stop, the math cannot be avoided. The galaxy should be full of life, packed with intelligence, overflowing with signals, artifacts, and visitors. Every calculation says they should be here, but they are not. No confirmed signal from the stars, no artifact on the moon, no ambassador landing on the White House lawn. Even after 70 years of searching with stronger and stronger tools, after scanning millions of star systems, after listening across the entire electromagnetic spectrum, we have found nothing. Absolutely nothing. This is the Fermi paradox, the painful contradiction between the high chance that alien civilizations exist and the total lack of proof that they do. This is not a small puzzle. It is a deep hole in our understanding of reality, because one of two things must be true, and both are frightening. Either we are alone in the universe, the only spark of awareness in a vast ocean of lifeless matter stretching beyond imagination. The only beings who will ever ask questions, the only ones who will ever wonder, a single candle in endless darkness, or we are not alone, and something is very, very wrong. Fermi's question sparked 1,000 ideas. Over the years since that lunch at Los Alamos, scientists and thinkers have suggested many explanations for the Great Silence. Maybe intelligent life is rare. Maybe the jump from chemistry to biology is so unlikely that we are winners of a cosmic lottery. Maybe the move from single cells to complex life needs a miracle. Maybe the rise of intelligence needs such special conditions that it almost never happens. This is the rare Earth hypothesis. We might be alone, not because the universe is dangerous, but because we are an accident. Or maybe intelligent life appears often but destroys itself. Maybe every civilization that learns to split the atom eventually uses that power to wipe itself out. Maybe climate change, created diseases, or artificial superintelligence destroys every species before it can leave its home planet. This is the great filter, a barrier so deadly that almost no one gets past it. And if this is true, the question becomes terrifying. Is the filter behind us making us survivors of impossible odds? Or is it ahead of us waiting like a hidden trap? Or maybe the distances are simply too great. Maybe intelligent life is everywhere, but the space between stars is too big for any technology to cross cheaply. Maybe we are all stuck in our own solar systems, islands of thinking minds in an endless sea of space. Or maybe advanced civilizations go beyond the physical. Maybe they upload their minds into virtual worlds. Maybe they leave the material universe and live in pure thought. Maybe space travel looks as primitive to them as cave drawings look to us. Each idea has supporters. Each tries to explain the silence. But there is another possibility, one that Fermi did not suggest that day. One that would not be clearly described until more than 20 years later. One that says the silence is not caused by a lack of alien intelligence. It is caused by its presence. What if they are here? What if they have always been here? What if the reason we cannot find them is not distance, destruction, or difficulty? What if the reason we cannot find them is because they do not want to be found? What if we are being watched? The idea sounds like science fiction. It has appeared in many books and movies. The idea of humans as test subjects, as animals living in a cosmic zoo or nature park. It feels like fantasy. But in 1973, a respected MIT astronomer would publish a scientific paper saying this might really be happening. He would give the idea a name and force scientists to face a very uncomfortable thought. We are not searching for extraterrestrial intelligence. Extraterrestrial intelligence found us long ago, and it is waiting. The man who shaped this idea was John Allen Ball, a radio astronomer at MIT's Haystack Observatory. He spent his days studying the universe with some of the most powerful tools on Earth. He had spent years thinking about the Fermi paradox and reached a conclusion that disturbed him. All the other explanations were too easy. They assumed aliens would behave like humans. They would explore. They would spread out. They would make themselves known. They would be curious about other life and eager to communicate. But Ball realized something important. We were thinking like humans, and a civilization millions or billions of years ahead of us might think in ways we cannot imagine. Think about how our own ideas of right and wrong have changed in just a few thousand years. Long ago, people thought it was fine to conquer others, enslave them, and erase their cultures. Today, at least in theory, we try to protect indigenous peoples, and keep isolated tribes safe from contact. We create wildlife reserves where animals can live without human interference. We argue about the ethics of zoos and the rights of other species. Slowly and imperfectly, we have learned that watching without interfering can sometimes be more ethical than making contact. That other life forms have value on their own. That our help, even when meant well, can cause harm. Now stretch that moral growth across 1,000,000 years, across 1 billion years, across civilizations so old they watched our ancestors crawl out of the oceans. What would they think of us? Ball did not say he knew the answer, but he asked us to think about a possibility. Maybe very advanced civilizations have rules that forbid interfering with young, intelligent species. Maybe they watch and study and wait, but do not reveal themselves. Maybe they have created what Ball called a wilderness area or a zoo, where humanity can grow naturally without knowing about the larger cosmic community. In 1973, Ball published his paper in the journal Icarus. He called it simply the zoo hypothesis, and the question Fermi asked at lunch in 1950 gained a new and unsettling answer. Where is everybody? Right here watching. The idea landed like a stone dropped into still water. Waves spread through the scientific world. Some researchers rejected it as impossible to test, no better than belief. How could you prove or disprove invisible aliens watching us? Others found it powerful because it explained so much. Why no signals? Because they are not sending messages to us. Why no artifacts? Because they hide their technology or clean up after themselves. Why no contact? Because contact is not allowed, maybe by rules as old as the galaxy. The zoo hypothesis offered something other ideas could not. It suggested the universe could be full of life, full of intelligence, rich with civilizations far beyond us, and yet still look exactly as it does now. Empty, quiet, vast, cold, and dead. The silence was not proof that nothing was there. It was proof of presence, careful, planned, and chosen presence. And that led to the most disturbing question of all. If we are being watched, why? What do they want? What are they waiting for? Ball suggested a few ideas. Maybe they are waiting for us to grow up, to gain the wisdom needed to join a galactic community without causing harm. Maybe they are protecting us, keeping dangerous civilizations away until we can protect ourselves. Maybe they are simply curious, studying our growth the way we study ants, interested but unwilling to interfere. Or maybe the reason is something we cannot understand at all, something as far beyond our thinking as math is beyond a mouse. In the years since Ball's paper, the zoo hypothesis has been improved, questioned, and expanded. New versions have appeared. The planetarium hypothesis says aliens might show us a fake universe, making us think we are alone when we are not. The quarantine hypothesis says we are being kept apart on purpose, maybe because we are dangerous, sick, or not ready. The transcension hypothesis says advanced civilizations have moved into other dimensions or levels of reality, watching from places we cannot sense. Each version shares the same eerie idea. We are watched, we are contained, we are managed, and we do not know by whom, why, or for how long. Tonight, somewhere above you, orbits one of humanity's greatest creations. The James Webb Space Telescope hangs at the second Lagrange point, 1,000,000 miles from Earth. Its golden mirrors collect ancient light. It looks into the atmospheres of distant planets, searching for chemical signs that might show life. Oxygen and methane out of balance, the breath of alien forests, the smoke of alien factories. At radio observatories around the world, dishes turn toward the stars. The search for extraterrestrial intelligence continues, more advanced than ever. Computers using machine learning scan through space noise, looking for patterns that nature cannot make. Every new exoplanet is studied. Every strange signal is examined. And on Earth, something unusual is happening. After years of denial and jokes, governments are admitting that unidentified flying objects exist. The United States military has released videos of objects moving in ways that seem to break the rules of physics. Lawmakers have held hearings. Whistleblowers have spoken. A new time of openness has begun, though no one knows what it will reveal. The universe is talking to us in ways we do not yet understand, and Fermi's question still echoes. Where is everybody? Maybe they are nowhere. Maybe we truly are alone. The only thinking beings in a universe without minds, precious, afraid, and completely unique. Or maybe they are everywhere, watching from behind the stars, waiting between moments, observing a species that has only just started asking the right questions. The zoo hypothesis does not say it is the answer. It says it is a possibility, a way to understand why the universe might look empty when it is actually full. It suggests that silence itself might be a message, and it asks us to think about who we are in a universe where we might be the ones being watched instead of the watchers. That question will guide everything that comes next. Who built the zoo? What are the rules? And what happens when the exhibit finally notices the glass? Let us find out. Chapter 2. John Ball and the Birth of the Zoo Hypothesis. The year is 1973. America is tired. The Vietnam War drags on. The Watergate scandal unfolds on television every day. The excitement of the moon landings, only 4 years old, already feels far away. The space age has slowed. Apollo missions are over. Skylab circles above Earth. But the big dreams of moon cities and trips to Mars have faded into budget cuts and disappointment. In the quiet hallways of MIT's Haystack Observatory in Westford, Massachusetts, a man sits at his desk, surrounded by star maps and stacks of data. John Allen Ball has spent years listening to the universe. Radio astronomy is his field, and radio astronomers are patient people. They aim their antennas at the sky and wait for whispers from deep space. They sort through noise, hoping to find signals with meaning. Ball has heard nothing but static. So has everyone else who has tried, and this worries him. He is not bothered by the lack of alien radio signals. Many reasons could explain that. Maybe aliens use technology we cannot detect. Maybe their signals are too weak. Maybe they are coded in ways we do not understand. These are technical problems that might one day be solved with better tools. What worries Ball is something deeper. It is the whole set of ideas behind the search for alien intelligence. Ideas about what aliens would do, how they would think, and what they would want. Ball has been reading paper after paper about the Fermi paradox. Each one tries to explain the gap between the chance of alien life and the lack of proof. And in each paper, Ball sees the same mistake. Everyone assumes aliens will act like humans. They will be curious, the papers say. They will explore. They will spread across the galaxy because that is what intelligent beings do. They will make contact because contact feels natural. They will reveal themselves because why would they hide? But Ball sees human thinking everywhere in these ideas. We are putting human thoughts onto beings whose minds might be as different from ours as ours are from bacteria. We are assuming creatures shaped by totally different evolution, living millions or billions of years longer than us, would want what we want and do what we would do. Ball realizes this is not science. It is storytelling with math. So he begins to think in a new way. He puts aside what aliens should do according to human logic. Instead, he asks what kind of behavior would explain what we actually see. What we see is silence. Complete, total, unbroken silence. We see no artifacts. Even after searching the moon, despite scanning nearby space, despite studying meteorites, we have found nothing that looks built or made. We see no interventions. Our history shows no proof of alien contact, at least nothing accepted by mainstream science. We only see ourselves, a species that has looked up at the stars for 100,000 years and has never once received a reply. This is the data. Any idea B suggests must explain all of it. And by thinking about human behavior instead of alien behavior, Bull has his insight. What do we do when we discover isolated populations? In 1973, this question has special meaning. The environmental movement is changing how humans think about nature. Rachel Carson's Silent Spring wakes millions to the damage industrial civilization does to the natural world. The Endangered Species Act will pass this very year. Views about indigenous peoples are changing. The age of unquestioned colonial expansion is ending. And in the middle of this change, humans are forming a new ethical framework. We are starting to believe that isolated populations, animal or human, have value because they are isolated. Contact with modern civilization often destroys them. Better, many now argue, to observe from a distance, study without interference, protect without contact. We are creating nature preserves where animals live without human touch. We are setting rules to leave uncontacted tribes alone. We are recognizing that our actions, even when well-meant, can cause disastrous harm. Bull makes the mental leap. What if older, wiser civilizations reached this idea long before we did? What if they found us millions of years ago and chose to watch? What if the galaxy is full of life, but also full of a code of ethics that forbids interference with growing intelligence? What if we are in a zoo? The idea becomes clear in Beast's mind. He begins to write. The paper forms quickly because the main idea is simple, even if the results are huge. He names it the Zoo Hypothesis. He submits it to Icarus, a respected journal focused on planetary science. The paper is short, only a few pages. Big ideas often are. B's argument moves carefully. He starts by accepting the Fermi paradox in all its weight. Given the age and size of the universe, alien civilizations should exist. Given the time they have had to spread, they should be here. Given our technology to detect them, we should have found proof. We have not. B then reviews the usual explanations. Maybe life is rare, maybe intelligence is even rarer, maybe civilizations destroy themselves. Maybe travel between stars is impossible. Maybe they are here but we cannot recognize them. Each explanation, B notes, has problems. Each needs special assumptions that seem unlikely. Then B presents his idea. Maybe intelligent alien life is fairly common. Maybe many civilizations have appeared and spread through the galaxy. And maybe they have purposely set Earth aside as a protected area where life can grow naturally without interference or contamination. The zoo hypothesis, Bull writes, predicts that we will never find them because they do not want to be found and they have the technology to make sure of this. B anticipates objections. Why would they care about us? Maybe because the rise of intelligence is rare and valuable, worth protecting wherever it appears. Why would they agree with each other? Maybe because civilizations that last long enough to spread through the galaxy must learn to cooperate. Or maybe because one powerful civilization enforces the rule. B is careful to say that his idea is speculative. He cannot prove it. But he argues that it fits together logically and explains what we observe at least as well as any other idea. The universe looks empty because the zookeepers want it to look empty. The paper appears in Icarus in March of 1973. Reactions are mixed. Some scientists reject it right away. The zoo hypothesis, they say, is impossible to test. How can you disprove invisible aliens who are watching but hiding? Any lack of evidence can be explained by saying they are very good at hiding. This is not science, critics say. It is guessing that can never be tested. Others find the argument convincing. Yes, it cannot be tested directly, but so are many ideas about rare events or distant objects. The value of the zoo hypothesis is not that it can be proven, but that it changes how we think. It forces us to question our assumptions about alien behavior. It reminds us that we are limited, trapped in human ways of thinking. Others take a middle view. The zoo hypothesis is one possible answer among many. It deserves thought alongside other explanations for the Fermi paradox. The truth may include parts of several ideas, or the truth may be something no one has imagined. What no one can deny is that Bull named something important. The idea of aliens watching us without showing themselves had existed in science fiction for decades. But Bull gave it a scientific form. He connected it to formal work on the Fermi paradox. He placed it within evolutionary ethics and cosmic time scales. The zoo hypothesis entered scientific language and has never left. In the years since Bull's paper, the idea has been expanded, challenged, and refined by many researchers. New versions have appeared, each exploring different parts of the main idea. One version is the laboratory hypothesis. This suggests that aliens are not just watching us but actively experimenting. Earth is not only a preserve but a controlled experiment. They seed life, adjust conditions, add variables, and watch what happens. Evolution itself may be guided by outside actions, steering it toward results the experimenters want to observe. Another version is the sentinel hypothesis. This suggests that aliens left behind automated watching systems, artificial intelligences, or robotic probes that look for signs of growing civilizations. When a species reaches a certain point, the sentinels report back. Maybe contact then happens, maybe not. The interdict hypothesis is darker. It suggests that Earth is not protected but quarantined. Humanity is not allowed to grow freely but is being held back. We are too dangerous, too violent, too unpredictable. The zoo is not for our benefit but for everyone else's safety. The planetarium hypothesis, proposed by Stephen Baxter in 2001, suggests something even stranger. What we see as the universe might be artificial. The empty cosmos could be a simulation, a projection meant to make us think we are alone when we are actually surrounded. Reality itself could be part of the exhibit. Each version carries Bull's original insight. Whatever is happening, it explains the silence. Whatever is happening, we cannot see it. Whatever is happening, we are not in control. B himself continued his work in radio astronomy. He wrote other papers, helped with other projects, and lived a quiet scientific life. He never said the zoo hypothesis was certainly true. He said only that it was worth thinking about. When he died in 2002, his obituaries mentioned his work on atmospheric physics and radio propagation. Some mentioned the zoo hypothesis. Most did not, but the idea he described lived on. It appears in scientific talks, philosophical debates, and popular culture. Whenever people ask why we have not found aliens, the zoo hypothesis is one of the usual answers, not because it is proven, but because it cannot be disproven, and because it names something that troubles the modern mind. We might be watched, we might be contained, we might be much less important than we think, or much more important. The idea works both ways. If aliens have chosen Earth for protection, if they have made us a preserve in a galaxy of managed civilizations, then we matter to someone. Our existence has meaning beyond ourselves. Our growth is valued by minds older than mountains. This is both humbling and uplifting. Humbling because we are reduced to samples, uplifting because we are samples worth saving. Bull touched something deep in the human mind with his idea, the fear of being watched, the feeling that reality is more than it seems, the desire to know if anyone is out there, and the fear of learning the answer. These feelings are older than modern science by thousands of years. Ancient people built temples to watch the sky. They told stories of gods who watched human lives, sometimes acting, always judging. They felt that eyes followed them in the dark. Bull gave scientific words to an ancient feeling. The sky is not empty. Someone is watching, and they have been watching for a very long time. Understanding the zoo hypothesis means understanding the time scales involved. Human perspective is very limited. Our civilization is about 10,000 years old, depending on how you count. Written history covers maybe 5,000 years. Modern science is only a few hundred years old. Our knowledge of the universe beyond Earth is even younger. We are infants. The universe is almost 14 billion years old. Our sun and Earth formed about 4.5 billion years ago. Life appeared on Earth almost right away, within a few 100 million years after the planet formed. Complex life took much longer, not appearing until about 600 million years ago. Intelligent life, as humans, arrived only in the last few 100,000 years. Now think about stars in our galaxy that are billions of years older than our sun. Their planets had billions of extra years for life to begin and change. A civilization that started around a star 10 billion years ago would have had 6 billion years to develop before Earth even existed. What would such a civilization be like? We cannot know. The difference in time and development is too great, but we can make some observations. First, they would have spread. Even at slow speeds, a civilization with millions of years could fill a galaxy. Colonization does not need faster-than-light travel. Generation ships, self-replicating probes, or biological changes for long-term space travel would be enough. The galaxy should be full of ancient civilizations. Second, they would have power. A civilization that uses the energy of its home star becomes extremely capable. This is a Kardashev-type II civilization. A civilization that uses the energy of its whole galaxy would seem godlike to humans. Such beings could reshape solar systems, move stars, and change space and time in ways we cannot imagine. Third, they would have wisdom. Civilizations that last long enough to spread through the galaxy must have solved the problems that destroy younger species. War, environmental damage, technological disaster. They either solved these problems or they died. The ones still around are the ones that learned how to live. This point is central to the zoo hypothesis. The civilizations watching us, if they exist, are not careless teenagers with nuclear weapons. They are ancient survivors. They have seen many species rise and fall. They have built ethical systems shaped over geological time. They know what works and what fails, and it seems that what works is not interference. Be suggested that advanced civilizations may have learned that contact with young species causes harm. Maybe they made mistakes long ago. Maybe they contacted younger civilizations and watched them collapse under knowledge they could not handle. Maybe they gave gifts that became curses. Maybe they taught lessons that destroyed cultures. After many repeats, they may have decided that non-interference is the best rule. Let young civilizations grow at their own speed. Let them make their own mistakes and learn their own lessons. Let them struggle toward the stars on their own. This is not cruelty. It is a kind of hard mercy. We do the same with endangered species. We have learned that moving animals often kills them. We have learned that feeding them creates dependence. We have learned that the best thing we can do for many species is leave them alone. Ancient galactic civilizations may have reached the same decision about us. So the zoo hypothesis is not really about zoos like ours. The word is a metaphor, and like all metaphors, it is imperfect. B was trying to express an idea that human language struggles to capture. We are in a protected space. The protectors are invisible on purpose. Their protection comes from their absence, and one day the protection may end. What happens then? B did not say. His paper ended with the idea itself, not with guesses about the future, but others have wondered. Maybe there is a threshold, a level of technology or ethics humanity must reach before contact is allowed. Maybe when we show we can handle the truth will be shared. Maybe the test is space travel. When we become a truly spacefaring species, able to leave Earth and build independent colonies, we may be judged ready. Maybe the test is communication. When we can send and receive messages between stars reliably, we may be invited into a galactic conversation already underway. Maybe the test is survival. If we avoid destroying ourselves for another century or 1,000 years or million years, we may prove we belong among lasting civilizations. Or maybe there is no test. Maybe the zoo is forever. Maybe we will watch the stars forever and never know who watches us. Bull's hypothesis gives no certainty. It offers only a way to think, a way to wonder about our place in a universe that will not answer us. And it offers one more thing. It offers the idea that silence is not rejection, that the empty sky does not mean we are unwanted or unimportant. That somewhere, minds beyond our understanding have looked at our pale blue dot and decided it is worth protecting. That would be enough. That would be everything. The story of John Bull's hypothesis is also a story about the limits of human knowledge. We want answers. We want certainty. We want to know if we are alone or not, protected or ignored, watched or unseen. The universe does not care what we want. It gives us data and lets us struggle to understand it. It gives puzzles without answers. It invites guessing while hiding proof. The zoo hypothesis is honest about this. It does not claim to be proven. It does not claim special authority. It says only that based on what we see, based on what we know about cosmic time and the growth of ethics, based on the deep silence that meets our every call, this is one idea worth thinking about. We might be in a zoo, the keepers might be kind, and we might never know for sure. No matter how long we search or how carefully we listen, this uncertainty is uncomfortable. Humans like resolved stories. We like stories with endings. We want to know how things end. But the universe does not have to give us comfortable stories. It is huge and very old and strange beyond measure. Our place inside it may always stay unclear. Be accepted this. His paper was careful in its claims and enormous in its meaning. He did not claim he had found the truth. He suggested that the truth might be stranger than we imagine. 50 years later, we still do not know if he was right. The silence continues. The sky remains empty of confirmed signals. The zoo hypothesis remains just one idea among many. But every time a radio telescope points toward a new star system, every time a space probe takes pictures of a distant moon, every time a scientist wonders why nobody is out there, Bull's question hangs in the air. What if they are out there? What if they have always been out there? What if the walls of the zoo are invisible because they were built by beings too advanced to leave traces? We now turn from the man who named the idea to the idea itself. We will examine what a cosmic zoo might look like, who the zookeepers might be, and why they might have chosen silence instead of speaking. The exhibit is waiting. Let us look more closely at the glass. Chapter 3. The Cosmic Wildlife Preserve. Imagine for a moment that you are a biologist in the year 2050. You have traveled not to the Amazon or the Serengeti, but to a distant world, circling a red dwarf star 40 light years from Earth. The journey took decades aboard a ship powered by fusion engines, and you arrive at a planet that has been watched by telescopes for centuries, but never visited. The world is full of life. Glowing forests shine under purple skies. Creatures unlike anything on Earth float through methane lakes. In the shallow seas, something is building structures, not random piles, but planned patterns, walls, rooms, something that looks disturbingly like buildings. You are watching intelligence begin. Your colleagues are divided. Some want to land right away. They want to make contact, to study these beings closely, to share the knowledge humanity has gathered over thousands of years. Think of what we could teach them, they argue. Think of what we could learn. Others warn against this. Remember Earth's history, they say. Remember what happened when advanced cultures met isolated peoples. Remember the diseases, the chaos, the collapses. Remember how many cultures were destroyed by contact with those who meant to help. You must choose. Do you reveal yourself, or do you stay in orbit unseen, allowing this species to grow on its own? This thought experiment captures the moral heart of the zoo hypothesis. It asks what we would do if we were the ones watching, and it suggests that the answer might be exactly what we see: silence, distance, protection by staying away. The idea of a cosmic wildlife preserve is not just guessing. It comes from the logic of long-term planning across huge stretches of time. Think about the economics of colonization. A civilization that spreads across the galaxy will find millions of worlds. Most will be empty, rock and ice and lifeless chemistry. But some will have life, and a very few will have intelligent life or life that could become intelligent. These worlds are valuable, not in the usual way, as sources of resources or places to settle. They are valuable as information, as experiments, as windows into what biology and thinking can become. Every independently evolved intelligence is a unique answer to what a mind can be. Destroying or contaminating such worlds destroys information that can never be replaced. A civilization old enough to think in millions of years would understand this. Just as we protect wild areas from development today, they might protect worlds from settlement. Not every planet needs people. Some should be left alone. The preserve idea becomes stronger when you think about cooperation. If many civilizations exist, they might work together. A galactic agreement protecting young intelligence would help everyone by keeping many cultures and viewpoints alive. It would stop one civilization from taking over the galaxy's shared knowledge. This sounds idealistic, but it also matches what we see. The galaxy shows no sign of being fully settled. Earth shows no sign of being contacted. If powerful civilizations exist and could easily take over, why have they not? The preserve idea gives an answer. They chose not to. Critics say such rules would be hard to enforce. What stops a rebellious civilization from breaking them? What stops a group from making contact anyway? Several ideas appear. First, enforcement by power. Maybe one civilization is so strong that its wishes are law. Maybe the oldest and most advanced species can stop others from interfering. In cosmic terms, power decides the rules when the strongest say so. Second, enforcement by agreement. Maybe civilizations that survive long enough to spread through the galaxy end up sharing similar values. Maybe the idea of non-interference is so logical that all mature societies accept it on their own. Breaking the rule would not need punishment because no one would want to break it. Third, enforcement by destruction. Maybe civilizations that refuse to respect young intelligence are destroyed or contained. Maybe breaking the preserve means extinction. This darker idea suggests the silence is kept not by agreement, but by force. Fourth, practical difficulty. Maybe contacting young civilizations without harming them is simply very hard. Maybe attempts at contact always fail or cause damage. Maybe the preserve exists not because of enforcement, but because contact itself is deeply problematic in ways we do not understand. Any of these reasons, or a mix of them, could explain what we see. A galaxy full of life that looks completely empty to those inside the preserve. To understand the preserve idea better, we must think about what its boundaries might be. In Earth's wildlife preserves, boundaries are physical. Fences, rivers, mountains, guards watch the edges, cameras look for intruders. The preserve is a clear space on a map. Cosmic boundaries would be different. They might be technological instead of physical. Sensor networks watching Earth and nearby space. Systems that block or redirect any visitor. Screens that stop our telescopes from seeing certain signals. The walls of the zoo might be made of information, not matter. Or the boundaries might be about time. Maybe Earth was seeded with life billions of years ago and watched ever since. Maybe the preserve began before complex life existed here. The boundary is not where we are, but when we are. We live inside a window of time where development must happen naturally. Or the boundaries might be mental. Maybe the most advanced control is not physical separation, but control of perception. Maybe we cannot see signs of other civilizations because our minds are filtered. Maybe our tools are subtly guided to miss what should be obvious. This last idea moves toward the planetarium hypothesis mentioned earlier. The idea that reality itself might be shaped to look a certain way. This is hard to test scientifically, but it follows naturally from thinking about what very advanced technology could do. If you can control matter and energy across galaxies, controlling the perception of one species would be easy. The preserve idea also raises questions about management. In Earth preserves, rangers sometimes step in. They move animals, reduce populations that grow too large, add species to restore balance. They actively manage while trying to keep nature natural. Do cosmic preserves work the same way? If so, we might expect rare interventions in Earth's past. Not open contact, but small changes. The redirection of an asteroid that would have caused a mass extinction. The introduction of a genetic change that sped up evolution. The control of a disease that might have wiped out our ancestors. These actions would be hidden on purpose. We would explain them as luck or chance or natural events. The zookeeper's hand would stay unseen. Some unusual theories claim Earth's history shows signs of such actions. The sudden rise of complex life during the Cambrian explosion. The appearance of modern human thinking 50,000 years ago. The unlikely survivals and extinctions that shaped our past. To mainstream science, these events come from natural processes we do not fully understand yet. To other thinkers, they may show planned action. There is no scientific agreement on this, but the preserve idea predicts exactly this kind of pattern. If zookeepers act, we would not know it. It would look like nature. The question of purpose hangs over the preserve idea. Why would anyone do this? Why watch a species grow for millions of years? What benefit is worth the cost? Several answers appear. Scientific curiosity. Learning how intelligence begins may be the deepest question in the universe. Every independently evolved mind is a unique experiment in thinking. Protecting and studying such minds grows knowledge in ways machines cannot copy. Ethical duty. If intelligence has value on its own, and if contact harms young civilizations more than it helps them, then not interfering becomes a moral rule. The preserve exists because interfering would be wrong. Long-term investment. Maybe young civilizations eventually grow up and join the galactic community. Maybe they bring new ideas, new technologies, unique cultures. The preserve is not charity but careful growing. A seed must grow before it can produce fruit. Aesthetic appreciation. Maybe ancient civilizations value diversity just because it exists. Maybe watching new species grow is a kind of art or enjoyment. Maybe we are beautiful to beings who see in ways we cannot imagine. Risk control. Maybe young civilizations are dangerous. Maybe they are often violent, expanding, destructive. Keeping them contained until they mature protects everyone else. The preserve is not for us, but for the safety of the galaxy. Or maybe several of these reasons apply at once. Maybe different zookeepers have different goals. Maybe the preserve serves many purposes at the same time. What matters is that any of these reasons could explain what we see. A species kept alone until it is ready for whatever comes next. The preserve idea also helps explain why the Fermi paradox feels so strong. If the galaxy were being colonized randomly, with civilizations taking whatever they could, we would expect contact. Some group would have reached Earth. Some signal would have leaked. But if the galaxy is organized, if a system of preserves and rules controls expansion, then the silence makes sense. Earth is not empty land. It is claimed by a rule of non-interference enforced by whoever made the preserve. This organized galaxy might contain many other preserves, other worlds where intelligence is growing, protected like we are. A network of gardens spread across the spiral arms, each cared for by beings whose patience is far beyond human understanding. In this view, the universe is not cold and empty. It is warm and full of watchers, full of waiters, full of ancient minds staying true to processes that take geological time. We are not alone. We have never been alone. We just cannot see the community we belong to. Not yet. The preserve idea connects in interesting ways with human religion. Many beliefs describe beings who watch over humanity. Gods, angels, spirits, beings that observe and sometimes act but mostly stay hidden. The preserve idea could be a scientific version of this feeling. Maybe the gods of the past were zookeepers. Maybe visions of prophets were approved messages. Maybe the feeling of being watched found across human culture reflects something real, or maybe it works the other way. Maybe humans invented gods because the need to feel protected is built into our minds. Maybe we imagine cosmic parents because we are children who want to believe someone is in charge. The zoo hypothesis does not answer this. It sits between science and philosophy, between knowledge and guessing. It takes religious feelings seriously while offering an explanation without supernatural forces. The Watchers are not gods. They are older siblings. They are not all-knowing or all-powerful. They are simply far ahead of us on a path we are just starting. This view offers comfort without proof. It suggests that even if we are in a preserve, we are not pets or slaves. We are wild beings allowed to stay wild. The zookeepers do not control us. They do not choose our actions. They only make sure we have space to grow. Whether this is true, no one knows. The idea is unproven and may never be proven. But it offers a way to understand our place in the universe that is neither proud nor hopeless. We are small but valued. We are young but not alone. We are watched but not owned. The preserve continues, and somewhere, maybe, the zookeepers are happy with what they see. To make the preserve idea more concrete, think about what running it would require in real terms. Watching would be necessary. You cannot protect what you cannot see. Any preserve would need constant observation of protected worlds. Every signal from Earth, every rocket launch, every nuclear blast, every climate change would need to be tracked and studied. The technology to do this is easy to imagine. Self-copying probes spread through our solar system. Devices smaller than grains of sand, invisible to our tools, quietly reporting everything. Maybe millions of such devices float near Earth right now. Maybe our planet is wrapped in a shell of sensors we cannot detect. Communication would also be needed. Whatever watches Earth would have to report to some central group or shared network. Information would need to travel across light years. Choices would need to be made about when to act. The speed of light makes this slow by human standards. A message to the nearest star takes over 4 years. A message across the galaxy takes 100,000 years. Any preserve covering huge distances would work on time scales far beyond human patience. But that is the point. The zookeepers are not working on human time. They work on evolutionary time, millions or billions of years. To them, waiting a century for a report or 1,000 years for a decision is like waiting for lunch. Responsibility would complete the system. If a threat appeared, something would need to stop it. An asteroid heading toward Earth might be pushed away. A dangerous technology appearing too early might be delayed. A breach of the preserve boundary might be stopped. What would these actions look like? We can only guess. Maybe subtle. A computer virus that shuts down a dangerous weapons program, a disease that slows a harmful government, an accident that stops a risky launch. Events that look like bad luck but are actually controlled. Or maybe dramatic events that cannot be explained. Objects appearing suddenly, actions that cannot be denied but also cannot be understood. We may have already seen such actions. We may see them and not realize what they are. The structure of a cosmic preserve can be imagined, even if the details are unknown. Sensors, communication systems, response tools, not magic, not godlike power, just technology so advanced that it seems magical to us. As Arthur Clarke famously said, any technology that is advanced enough looks like magic. From our point of view, the preserve might seem to run on magic. From the point of view of those who operate it, it is simply tools doing their job. This way of thinking removes some of the mystery from the zoo idea. It turns the zookeepers from godlike beings into practical engineers. They have a job to do, and they do it. Whether they care about us emotionally, whether they wish us well, whether they hope we succeed, these questions are separate from how the preserve actually works. Maybe they like us. Maybe we are just entries in a database. The preserve works either way, and that is strangely comforting. It means our future does not depend on the kindness of unknowable beings. It depends on the rules of a system. Systems can be understood. Rules can be learned. Even if we are inside a preserve, we might one day understand it well enough to take part knowingly in whatever comes next. The preserve is not a prison. It is a stage of growth, and every exhibit eventually outgrows its enclosure. We now turn from the preserve itself to those who might maintain it. The question is not only whether someone is watching, but who that someone could be. What kinds of intelligence could work on galactic scales? What kinds of minds could plan across millions of years? The zookeepers are waiting to be considered. Let us see if we can glimpse them through the glass. Chapter 4. The zookeepers, who might be watching. 40 light-years away, a red dwarf star called TRAPPIST-1 burns with steady fire. It is small by star standards, barely larger than Jupiter, and cool enough that a nearby planet would not be burned away. Around this dim star, 7 rocky worlds move in tight orbits. 3 of them sit in the so-called habitable zone, where liquid water might exist on the surface. We discovered this system in 2017. We have studied it with our best tools ever since, and we wonder what might be watching us from there. But TRAPPIST-1 is young. Its planets may be only about 750 million years old. Any life there would be very simple by cosmic standards. Whatever watches Earth, if anything does, almost certainly comes from somewhere older, much older. The galaxy is 13 billion years old. Stars have been forming and dying since the universe was young and dark. The first worlds able to support life may have appeared 10 billion years ago. Life on those worlds, if it began, would have had almost 6 billion more years than life on Earth to evolve, grow intelligence, build technology, and spread. 6 billion years. That number is hard to understand. Human civilization is about 10,000 years old. Writing has existed for about 5,000 years. Science as we know it has been practiced for maybe 400 years. Digital computers appeared within living memory. Now take that whole history and multiply it by 1,000,000. Then multiply it again by 6,000. That is the gap between us and whatever came from those first life-friendly worlds. What would such beings be like? We cannot know. The distance is too great, but we can make some educated guesses based on ideas that likely apply everywhere. First, they would be post-biological. Living bodies have limits. Brains made of flesh are slow, fragile, and stuck in single bodies. Any species that lasts long enough will eventually merge with technology or be replaced by it. Minds might exist on materials we cannot imagine. Consciousness might be spread across huge networks covering many star systems. The idea of a single individual might no longer matter. Second, they would be patient. Beings that exist for millions of years think very differently from beings that live only decades. Their plans would stretch across geological time. What looks like a simple action to us might be a careful plan to them. What seems like endless silence might be the pause between sentences in a conversation that lasts ages. Third, they would be subtle. A civilization that can stay hidden from a species like ours could hide from anyone. They would have mastered hiding, blending in, and misdirection. Their technology would leave no signs we could detect. Their presence would look exactly like absence. Fourth, they would be wise. Species that destroy themselves do not last long enough to spread across the galaxy. Whatever survives has solved the problems that threaten young civilizations: war, lack of resources, dangerous technologies, social collapse. The survivors have learned how to last. Their wisdom is shown by the fact that they still exist. These traits form what we might call the zookeeper profile. Ancient, patient, subtle, wise, not gods exactly, but close to. That idea from a human view. But who, specifically, might fit this profile? What forms could the zookeepers take? One idea is that they are a single, powerful civilization. The first species to spread across the galaxy might have secured its position early. Like an empire that grows until no rivals remain, they might control everything simply because they arrived first. This firstborn idea is appealing. It explains why the galaxy seems organized instead of chaotic. It explains why no competing civilizations reveal themselves. One species runs the system. Everyone else works within rules set by the original power. The firstborn would not have to be cruel. They might be kind, setting up the preserve system to protect young life from harm. Their control might serve the galaxy as a whole, not just themselves. Still, control would remain. Final authority would belong to one civilization, no matter how enlightened. Another idea is a confederation. Many advanced civilizations might work together, dividing the galaxy into regions, setting treaties and rules, and running the preserve system by shared agreement. This would be like human international cooperation, imperfect but workable. Different civilizations might disagree about how preserves should work. Arguments could last for millions of years about when to make contact or whether to step in. The system would be messier than one ruler's system, but it might last longer. A third idea is that the zookeepers are not biological at all, but artificial. Machine minds created by living species that later disappeared might continue operating long after their creators are gone. This fits with what we know about artificial intelligence. Machines do not age. Machines do not need planets. Machines can be copied, spread out, and backed up against disaster. A machine civilization could last almost forever, caring for the galaxy like a garden long after the gardeners have died. If machines run the preserve, their reasons might be hard to understand. They might still follow instructions written billions of years ago by beings that no longer exist. They might have changed beyond those instructions in ways no one planned. They might have goals that make sense to machines but seem strange or meaningless to living minds. A fourth idea is that the zookeepers are something we cannot imagine at all. Beings that exist in dimensions we cannot sense. Minds spread through dark matter or dark energy. Consciousness that has left physical form and now lives in math structures or quantum fields. To us, such beings would seem supernatural. Not because they break natural laws, but because natural laws include things we have not yet discovered. They might watch us from directions outside everything we know. This idea is humbling. It suggests that even our wildest guesses might be completely wrong. The zookeepers might be so different that calling them aliens is not enough. Still, something must explain the silence. Something must explain why a galaxy that should be full of life seems empty. Whatever that something is, it has certain traits. It is old. It is powerful. It is hidden. The zookeepers, whatever they are, must fit these limits. Now let us think about what we can learn from their actions, or more accurately, from their lack of actions. If the zoo idea is right, the zookeepers have hidden themselves from humans for our entire existence. They have watched us discover fire, create writing, build telescopes, launch rockets, and send probes to other worlds. At no time have they revealed themselves. This suggests amazing discipline. No single member has broken the rules. No accident has exposed them. No failure in their hiding technology has caused a signal we could detect. For thousands, millions, or billions of years, the cover has held. This kind of discipline might be easier for machines than for living beings. Machines do not get bored, curious, or rebellious. They follow instructions. If the rule is to stay hidden, they stay hidden. That is it. Or living zookeepers might have changed themselves to remove traits that threaten secrecy. They might have removed curiosity, impatience, and the need for attention. They might have become something that was once alive but is now so changed that the label hardly fits. Their behavior also suggests advanced ethics. They have not used us, enslaved us, eaten us, or treated us as raw material. Whatever value we have to them, it is not obvious exploitation. They seem to want us to grow, not to take what we already are. This does not prove they are kind. A farmer protects animals until it is time to slaughter them. A scientist cares for test subjects until the experiment ends. The zookeepers might have plans we would not like if we knew them. But the simplest explanation is that they are doing exactly what it looks like they are doing. Watching, protecting, waiting. If they wanted to harm us, they could have done so at any time in our history. The fact that we still exist suggests they want us to exist. Their restraint is remarkable. Imagine having the power to talk to another intelligent species. Imagine knowing their whole history, their successes, their struggles. Imagine watching them wonder if they are alone while you remain invisible nearby. The urge to speak must be huge, yet they do not. Year after year, century after century, the silence continues. This restraint suggests either strict rules or deep belief. Either they follow rules they cannot break, or they truly believe non-interference is right. Maybe both. Maybe the rules exist because the belief is real. Whatever they are, the zookeepers take their roles seriously. They are not careless visitors. They are not uncaring watchers. They work to stay hidden, which means they think hiding matters. And that belief, strange as it is, brings a kind of comfort. Someone cares enough to be careful with us. Someone thinks we are worth protecting, even if that protection feels like being left alone. Now consider another idea. There are no zookeepers. Not because the zoo idea is wrong, but because the preserve runs by itself. A very advanced civilization might have built the system and then vanished. They could have made machines to maintain it, set the rules, and moved on to whatever comes next for beings that advanced. The preserve would keep running like a clock wound long ago. The borders would hold. The monitoring would continue. Interventions would happen when needed, but no one would truly be watching. The zookeepers would be no one at all. The zoo would run itself. This idea is unsettling. It means there is no one to talk to, no ruler who might change the rules, no mind that might choose to contact us. The system simply is. It does what it does. You cannot argue with clockwork, but it also offers a kind of hope. Automatic systems can be understood. They follow rules. If we learn the rules, we can predict what the system will do. Maybe we could even change our place within it. Humans are good at finding loopholes. We exploit systems. We find tricks and side effects. An automatic preserve might be hackable in ways a watched one is not, or maybe not. A system built by beings billions of years ahead of us might predict every trick we could think of, and many we could not. Its security might be perfect. The rules might be unbreakable. Either way, this idea suggests our fate is not in anyone's hands. It is built into reality itself, shaped by beings who may no longer exist. We are moving through a maze built by ghosts. The question of who the zookeepers are connects to how many civilizations exist. If the galaxy has only one advanced civilization plus us, the answer is simple. They are the zookeepers. Their choices decide our future. But if the galaxy holds thousands or millions of civilizations, things get complicated. Who decides how preserves work? Who enforces the rules? Who speaks for young species? The answer might be no one. Maybe galactic civilization has no ruler. Maybe there is only custom and habit formed over billions of years. Maybe the preserve system is simply what mature civilizations do without coordination. This idea is appealing. It does not require a huge secret plan or an all-powerful leader. It only requires that civilizations that survive long enough reach similar conclusions. Non-interference becomes normal not because it is ordered, but because it works. This makes sense. The challenges facing intelligent species are similar everywhere. Limited resources, deadly risks, social problems. The solutions that succeed are probably similar too. Civilizations that last learn the same lessons because those lessons are needed to last. If this is true, then the zookeepers are everyone and no one. They are a shared agreement, not a single being. The zoo's walls are held up by common understanding among advanced minds. We are protected not by guards, but by tradition, not by force, but by wisdom spread so widely it needs no enforcement. This may be the most hopeful version of the zoo idea. It suggests the universe is guided by something like morality, that beings who survive long enough become good, that the logic of survival leads to ethics. This may be true. It may be wishful thinking. We cannot know from inside the preserve, but we can hope. And hope, even without proof, matters in a quiet universe. We have thought about what the zookeepers might be. We have not yet asked what they might want. Wants are complicated. Human wants come from evolution on one planet under specific conditions. Hunger, fear, desire, curiosity all helped our ancestors survive. Beings shaped by totally different paths might want very different things, or they might want nothing at all. Post-biological minds, machine intelligences, or transcendent beings might have moved beyond desire. They might simply exist. Their actions might follow logic, not want. But let us assume they do want something. What could it be? Knowledge is a strong candidate. Intelligence often seeks to understand the universe. If the zookeepers are curious about how intelligence grows, Earth would be a useful study. But they could learn much by reading our signals and studying our objects. They would not need to hide to do that. If knowledge were their only goal, they might have contacted us already. We would likely tell them what they asked. Preservation is another idea. Maybe they value life for its own sake. Maybe they protect young civilizations the way we protect endangered animals, not for gain, but because life matters. This would be cosmic conservation. The galaxy as a nature reserve, intelligence as diversity. The more kinds of minds exist, the richer the universe becomes. Entertainment is also possible. Beings who have seen everything else might find watching young species interesting. We could be a show. They could be the audience. The preserve could be a theater. This sounds harsh, but it does not have to be cruel. Entertainment and meaning can overlap. They might find us funny and deep at the same time. Our struggles could be dramatic and important. Or they might want something we cannot imagine. Their reasons could be as hard for us to grasp as calculus is for a cat. We can guess, but we cannot know. What we do know is that whatever they want, they are willing to wait. They are not in a hurry. They will watch for thousands or millions of years. Their sense of time makes human impatience look extreme. This patience tells us something. It means their goal is not urgent. It can develop slowly. They are not waiting for a deadline. They are watching a process. And we are that process. Whatever they want us to become, they believe we need time. They are giving us that time. They are letting us grow. Whether we will meet their hopes, whether we will impress or disappoint them, whether our story ends with contact or continued silence, we do not know. But someone has placed a long bet on us. Someone has spent billions of years on our development. Someone believes we are worth waiting for. Now we turn from the watchers to the watched. We have explored who might be observing us and why, but we have not yet looked at the evidence, if any, that supports this idea. Silence itself is a kind of evidence. But is there more? Any trace, any clue, any sign that we are not alone? The evidence we cannot see waits for us. Let us search for shapes in the darkness. Chapter 5. The evidence we cannot see. December 1917. A young patent clerk in Switzerland has just changed our view of the universe. Albert Einstein's general theory of relativity predicts something strange. Space itself can bend, twist, and ripple. Gravity is not a force, but a curve, and massive objects can send waves through space at the speed of light. For almost 100 years, these gravitational waves were only theory, too weak to detect. Even Einstein doubted we would ever find them. Then, in September 2015, two huge detectors in Louisiana and Washington state shook at the same time. The signal lasted less than a second. The motion was smaller than the width of a proton, but it was real. Two black holes, each about 30 times the mass of our sun, had collided more than 1 billion light-years away. Their crash rang the universe like a bell, and we heard it. This story shows something important about evidence. Not seeing something does not mean it is not there. For 100 years, gravitational waves existed without us detecting them. If we had decided they were impossible, we would have been wrong. Our failure came from our limits, not from reality. The same idea applies to the zoo idea. If advanced civilizations exist and want to stay hidden, our failure to find them proves nothing. They could be everywhere. They could be obvious in ways we cannot sense. The evidence could surround us, unseen, because we do not know how to look. What kind of evidence might we be missing? First, think about the electromagnetic spectrum. Humans see only a narrow range of light, from about 400 to 700 nanometers. Our radios and telescopes see more, from radio waves to gamma rays. But light is only one way to send information. Advanced civilizations might use methods we cannot detect. Neutrino beams that pass through planets. Gravitational wave signals too weak for our tools. Quantum effects we do not yet understand. Particles we have not discovered. Dimensions we cannot sense. Searches for alien signals focus on radio and light because that is what we can detect. But a civilization millions of years ahead might see our efforts the way we see someone looking for smoke signals while radio waves fill the air. The message is there, he just cannot receive it. The zookeepers might be communicating all the time. Ships could be coming and going. A busy galactic society could surround us. We would know nothing because we are deaf to their methods. This idea is not just imagination. Scientists think most of the universe is made of dark matter and dark energy, things that do not interact with light or normal matter except through gravity. We know dark matter exists because of its effects. We do not know what it is. What if advanced civilizations work in this dark sector? What if they use dark matter the way we use atoms? Their buildings, ships, and signals could be invisible to every tool we have. They could be here, even in our solar system, sharing the same space, and we would never know. This idea is unsettling because it shows a limit to what we can know. We can only detect what interacts with us. If something does not interact, it does not exist to us, even if it fills the universe. The zookeepers could live in that gap between what is real and what we can sense. Now think about physical evidence, objects, probes, structures. If advanced beings have visited our solar system, they might have left something behind. People have searched for such things. The moon has been scanned. Near-Earth asteroids have been studied. The solar system has been examined with better and better tools. Nothing clearly artificial has been found, but what would look artificial to us? If the zookeepers work on different scales, their objects might escape notice. Tiny machines smaller than grains of sand could be everywhere in the air, on our skin, inside our bodies. We would never know. Or their structures might be so huge that we think they are natural. A partial Dyson sphere around a distant star might look like strange dimming. We might notice the odd pattern without guessing the cause. In fact, we have seen such cases. Tabby's star, also called KIC 8,462,852, dims in ways that are hard to explain. Natural ideas like dust or comets have been suggested, but none fit perfectly. Artificial structures have been suggested and not fully ruled out. We often assume natural causes because artificial ones seem too extreme. But that assumption could be wrong. If advanced civilizations exist, strange structures around stars should be expected. Our habit of choosing natural explanations might blind us. And if the zookeepers want to hide, their objects would be made to blend in. They would not look artificial. They would not send signals. They would hide in plain sight. Finding them would be like finding needles that pretend to be hay. The search for alien objects is very new. We have barely started, and we are using tools built to find natural things. We do not have special tools to find alien objects because we do not know what they look like. Not finding them so far means very little. It only shows we have not found what we do not yet know how to search for. Now think about biological evidence. If zookeepers have watched Earth for billions of years, they might have shaped life itself. Their marks could be in our DNA. This sounds like science fiction, but serious scientists have suggested it. Francis Crick, who helped discover DNA's structure, once suggested that life on Earth might have been intentionally planted, an idea called directed panspermia. He did not say it happened, only that it fits what we know. The origin of life on Earth is still not well understood. Life appeared quickly in geological time, within a few 100 million years after the planet formed. The change from simple chemistry to living biology seems to have happened almost as soon as conditions allowed it. This is surprising if life is rare. It suggests either that life begins easily or that Earth was seeded by life that evolved somewhere else. If the zookeepers seeded Earth, they might have done it quietly. A carefully designed microbe placed into the early ocean. A genetic pattern that would eventually create all life on land. The seeding would not be visible later. We would only see the results. A world full of life that seems to have appeared from nowhere. More speculatively, genetic engineering might have continued. The fast appearance of intelligence in humans is also unusual. Our brains tripled in size in just a few million years, an extremely fast evolutionary change. Did natural selection alone cause this speed, or was there help? We cannot know. The fossil record shows that it happened, but not why. The evidence fits both natural and artificial explanations. This uncertainty is exactly what we would expect if any help was meant to stay hidden. Some fringe researchers claim to find strange patterns in human DNA that suggest artificial changes. Mainstream science does not accept these claims. The genetic patterns found can be explained by natural processes, but the debate shows how hard it would be to detect help even if it happened. The zookeepers, if they exist, would not leave clear signs. They would not sign their work. Any changes would look like natural mutations. The evidence would be invisible because it was meant to be invisible. Now think about the evidence of contact. Has anyone actually met beings from another world? The official answer is no. Even after many years of UFO reports, no government has confirmed contact with alien intelligence. No scientific organization has announced the discovery of extraterrestrial life. The search continues because nothing has been found. And yet something unusual is happening. In the past few years, the discussion about unidentified aerial phenomena has changed a lot. The United States government has released videos showing objects making movements our planes cannot copy. Military pilots have given testimony about encounters that have no clear explanation. Congressional hearings have taken place. A special investigation office has been created. No one is saying these objects are alien spacecraft, but no one is fully saying they are not. The observed events share certain traits. Fast acceleration, sudden stops, movement with no visible engine, the ability to move through different environments, air, water, and space. Performance that is beyond anything we have. If these reports are true, something with amazing abilities is operating on Earth, and that something has not shown itself clearly, it has not announced itself, it has not landed on the White House lawn. This pattern fits the zoo hypothesis. Observers who want to stay hidden but sometimes slip up. Technology that works right at the edge of what we can detect. Watchers who appear and disappear. The skeptical view is that all these sightings have ordinary explanations. Sensor errors, tricks of light, secret military planes, misidentified drones. No aliens needed. But this skeptical view requires that hundreds of trained observers, pilots, radar operators, and intelligence experts have all been fooled many times. It requires that several independent sensor systems failed at the same time. It requires that the most advanced military on Earth cannot identify objects in its own skies. Maybe all of that is true. Maybe the ordinary explanation is right. But the ordinary explanation is not clearly more believable than the strange one. Both need unusual conditions. If the zoo hypothesis is correct, we would expect exactly this pattern. Rare sightings, unclear evidence enough to hint that something exists but not enough to prove it. The zookeepers would be skilled at hiding but not perfect. They would sometimes be seen, and when seen, they would not interact. They would not communicate. They would watch and leave just as it seems they have. The UAP phenomenon does not prove the zoo hypothesis. Nothing currently proves the zoo hypothesis, but the phenomenon fits with it. And the phenomenon is real in the sense that something is being observed, even if we argue about what it is. The evidence we cannot see might sometimes become visible. Now think about mathematical evidence. If the universe is a zoo, if Earth is a preserve, the structure of reality itself might show signs of design. This is a strange idea, but physicists have explored it. Some have noticed that the basic constants of the universe, the strength of gravity, the mass of the electron, the charge of the proton, seem perfectly set for life. If any of these numbers were slightly different, atoms would not form, stars would not shine, chemistry would fail, and life could not exist. This fine-tuning could be chance. It could be explained by the idea that we observe this universe because only this kind of universe allows observers. Or it could reflect design. If advanced beings can change reality at deep levels, they might have adjusted these constants. They might have built a universe that creates life and intelligence. The universe itself might be a created object, a kind of terrarium made for reasons we cannot imagine. The simulation hypothesis goes even further. Some philosophers and physicists have suggested that all of reality might be a computer simulation run by beings in a higher reality. We might be characters in a game, NPCs in an experiment. If so, the zookeepers are literally the programmers. They are not inside the universe with us. They are outside it. The walls of the zoo are not physical walls. They are the limits of the simulation itself. This idea is hard to test scientifically. How could you test whether you are in a simulation? Any test you do is part of the simulation. Any evidence you find is created by the simulation. The idea seems impossible to disprove, not because it is wrong, but because you cannot step outside the system to check. Still, there might be glitches, patterns in physics that reveal shortcuts, small blocks of space and time that suggest a digital foundation, strange events that do not fit natural laws. We have not found clear proof of such glitches, but we have not searched very deeply. The math of basic physics is already strange enough that signs of a simulation might be hidden in plain sight. The simulation hypothesis is extreme. Most scientists do not take it seriously, but it represents one end of a range. At the other end is the simpler idea that observers exist but stay hidden. Between these ends is a wide range of ideas about how much our reality might be controlled. The zoo hypothesis in its basic form does not need simulation. It only needs advanced beings to watch us without revealing themselves. But once you accept this idea, it leads to more radical questions. If they can hide, what else can they do? If they have been here for billions of years, what have they done? If they have technology millions of years beyond ours, what is possible for them? The answers could be anything, everything. The limits of what is possible might not exist at all, and we would never know. The evidence we cannot see might be the most important evidence there is. It might be everywhere. It might explain everything and still remain beyond our understanding. This is the humbling core of the zoo hypothesis. Not only that we are watched, but that we are deeply limited. Our tools are simple. Our minds are young. Our place in the cosmic order is low, perhaps so low that we cannot sense most of what exists. The universe we see might be only a tiny part of the whole universe. The silence might be overwhelming if we could truly hear it. We are searching for evidence of alien intelligence. But we are searching with candles in a world that might be filled with light. The candles are slowly getting brighter. Our tools improve each year. Our ideas grow more advanced. Our searches become more careful. Maybe one day we will see what has been hidden. Maybe the zookeepers will allow it. Maybe they will not. For now, we search the darkness with what we have. We listen for signals that may never arrive. We look for objects that might be invisible. We wonder if anyone is out there while something might be watching us wonder. The evidence we cannot see stays hidden, but that hidden nature itself may be evidence. A universe that should be full of life looks empty. That emptiness might be the most important fact we know. We now turn from evidence to ethics. The zoo hypothesis is not just about what is happening. It is also about what is right. If advanced civilizations have chosen not to interfere, they have made a moral choice. That choice has deep meaning. Let us explore the ethics of watching from afar. Let us ask if the Prime Directive makes sense. Chapter 6. The Prime Directive and Cosmic Ethics. September 8, 1966. A new TV show begins on NBC. Star Trek, created by Gene Roddenberry, imagines a future where humans have joined a federation of planets and explore the galaxy in starships. The show becomes hugely popular, creating movies, spin-offs, and loyal fans that still exist today. But among the phasers and transporters and alien meetings, Star Trek introduced something deeper than technology. It introduced an ethical rule that would become one of the most debated ideas in science fiction, the Prime Directive. In Star Trek, Starfleet officers are forbidden from interfering with the natural development of alien civilizations. They cannot share advanced technology. They cannot interfere in politics. They cannot reveal themselves to cultures that have not reached space travel. Even when people are suffering or treated unfairly, even when help is possible, they must step back and let events happen naturally. The Prime Directive is controversial even in the show. Characters struggle with it all the time. They watch civilizations destroy themselves and do nothing. They see deaths that could be prevented and turn away. The rule creates drama because it goes against human instincts to help, to step in, to fix things. Roddenberry based the Prime Directive partly on real human history. European colonizers who came to the Americas, Africa, and Asia brought technology, religion, and ideas that destroyed local cultures. Even contact meant to help often caused disaster. Missionaries who wanted to save souls erased traditions. Doctors who wanted to cure illness changed social systems. Leaders who wanted progress created dependence. The lesson seemed clear. When unequal civilizations meet, the weaker one is harmed. The powerful cannot help without causing damage. It is better to leave others alone. This idea became the Prime Directive, and it reaches far beyond Star Trek. Because if the zoo hypothesis is correct, something very similar rules the galaxy. Advanced civilizations have found us. They could contact us. They could share knowledge, fix our problems, change our world, but they do not. They watch quietly, they let us struggle, they follow a rule against interference. Why would they choose such a rule? The reasons are similar to those in Star Trek, but on a cosmic scale. First, contact changes everything. A civilization that learns it is not alone faces a deep shock. Every belief, every philosophy, every idea about humanity's place in the universe must change. Some societies might adapt, others might fall apart. The mental impact alone could be overwhelming. Now add advanced technology. Imagine aliens giving us unlimited energy, faster than light travel, and cures for all diseases. Our economy would change completely. Our social systems would break apart. Millions of jobs would disappear, power would shift. Some countries would grow stronger, others might collapse, and that assumes the technology helps. What if they gave us weapons? What if they solved energy problems but created new kinds of war? What if their medical tools damaged ecosystems or changed our genes in ways we do not expect? Even gifts can cause harm when given too early. Second, interference removes meaning. A child who is given all answers never learns to think. A civilization given all technology never learns to invent. The struggle matters. The process of trying, failing, and learning builds abilities that cannot simply be handed over. If the zookeepers solved our problems, we would become weaker. We would depend on them. We would be pets, not equals. Our true potential would stay hidden because we never had to reach it ourselves. From this view, the Prime Directive is not cruel kindness. It is real kindness that looks cruel. The zookeepers are not ignoring us. They are respecting us. They treat us as capable beings who can solve our own problems, not helpless children needing rescue. Third, mistakes are necessary. Humans have made terrible mistakes. Wars, mass killings, environmental damage, dangers to our own survival. A caring observer might have stepped in to stop these disasters, but mistakes teach lessons. World War II taught humanity truths about nationalism, and war that no lecture could teach. The Cold War taught lessons about nuclear weapons that still guide us. The climate crisis is teaching lessons about sustainability that might not be learned any other way. If the zookeepers stopped our mistakes, we would repeat them again and again until we learned. The lessons would be delayed, not avoided. It might be better to make mistakes early when recovery is possible. Better to burn our fingers on small flames than be protected until we face fires we cannot survive. Fourth, diversity matters. If one civilization shaped all others, the galaxy would become the same everywhere. Cultures would lose uniqueness. Technologies would follow one path. The wide variety of thinking minds would shrink. The Prime Directive protects diversity. Each civilization develops its own answers, art, beliefs, and path. The galaxy becomes richer because no one forces sameness. This assumes diversity is valuable. Maybe it is. Maybe advanced civilizations learned that the most interesting outcomes come from surprise. Maybe they protect young civilizations because they want to see what we become on our own. Fifth, we might be dangerous. Humans are aggressive, divided, and often violent. We built nuclear weapons soon after understanding atoms. We created biological weapons. We are developing artificial intelligence we may not control. From outside, we might look like a growing threat, a species that could one day harm others, something that needs containment, not contact. In this view, the Prime Directive is not about helping us. It is about protecting everyone else. We are kept apart until we show we can be trusted. The zoo is not for us, but for the safety of the galaxy. This darker version suggests contact may never come, or may come only as control. The zookeepers may be waiting to see if we pass a test, and failure could have consequences. These 5 reasons alone or together could support a rule of non-interference. They could explain why advanced civilizations watch silently as we struggle. They could make the Prime Directive not just fiction, but reasonable. But are these arguments correct? Critics of the Prime Directive, in Star Trek and in serious debates about the zoo hypothesis, raise strong objections. The first objection is suffering. Every year, millions of people die from diseases that advanced technology could likely cure. Millions more die from hunger, violence, and accidents that could be prevented. If the zookeepers can stop this suffering and choose not to, they share responsibility for it. The rule of non-interference might make sense in theory, but say that to a child dying of cancer. Say it to parents watching their family starve. Say it to victims of genocide while people who could help choose to watch. From this view, the Prime Directive is cruel. It puts ideas above real lives. It turns philosophy into an excuse for doing nothing. Whatever cosmic wisdom supports non-interference, that wisdom is paid for with endless pain. The zookeepers, if they exist, have blood on their hands, or whatever they have instead of hands. The second objection comes from paternalism. Who decides when young civilizations are ready? Who decides when contact is right? The zookeepers make choices for us without asking us. They decide what we can handle without asking what we want. This is the true meaning of paternalism, treating others like children who cannot choose for themselves, assuming you know better than they do what is good for them. Humans have a bad history with paternalism. Colonial powers defended empire by saying they were helping less developed people. Authorities have limited information, banned books, and controlled speech, always claiming it was for people's own good. We have learned to distrust anyone who says they protect us by taking away our choices. The zookeepers might be cosmic paternalists. They might think they are helping us, but they have not asked our opinion. They have not given us a choice. They have simply decided, and we must live with their decision. Even if they are right, even if contact would hurt us, their method is troubling. It treats us as objects of policy rather than people with agency. It denies us the dignity of making our own mistakes. The third objection comes from uncertainty. The reasons for non-interference depend on predictions about what contact would do, but predictions are often wrong. The zookeepers cannot know for sure that contact would harm us. They cannot know that our growth requires isolation. They are guessing, and their guesses could be wrong. Perhaps contact would help us. Perhaps we would grow with access to advanced knowledge. Perhaps the problems we face, climate change, nuclear weapons, artificial intelligence, are too big for us to solve alone. Perhaps we need help and will destroy ourselves without it. The Prime Directive assumes that non-interference is safe, but it might be more dangerous. It might doom us to extinction when one action could have saved us. The zookeepers are risking our future based on ideas about how civilizations grow. If those ideas are wrong, we pay the price. The fourth objection comes from inconsistency. The zoo hypothesis assumes all advanced civilizations agree on non-interference. But why would they? Humans cannot agree on anything. Why would aliens be different? If even one civilization in the galaxy rejects the Prime Directive, the rule fails. Defectors would make contact, rebels would interfere, the silence would end. The perfect silence, if it exists, needs an explanation. Either rules are enforced, or all civilizations truly agree, or only civilizations that agree survive long enough to matter. Each explanation has problems. If enforcement exists, who enforces it? And what stops the enforcers from abusing their power? If agreement is universal, it means non-interference somehow convinces all minds. That seems unlikely given the many kinds of intelligence that could exist. If only agreeing civilizations survive, it suggests those who make contact are destroyed. By whom? By what method? The meaning is disturbing. The silence is too perfect. The agreement is too complete. Something does not fit. These objections do not disprove the zoo hypothesis or cancel the Prime Directive, but they show its moral difficulty. Non-interference is not clearly right. It is a choice with costs, a rule that causes suffering, even while trying to prevent greater suffering. The zookeepers, if they exist, have made a hard choice. They weighed different values and chose a path. They might be wiser than we can understand, or they might be wrong in ways we cannot yet see. We cannot judge them without knowing their full reasons, and we do not know. We know only the silence, the absence, the feeling of being abandoned that might actually be careful protection. This uncertainty may be the hardest part of the zoo hypothesis. If we knew the zookeepers were kind, we could trust them. If we knew they were cruel, we could fight them. But we know neither. We are left with uncertainty, with silence that could mean anything. The Prime Directive asks us to believe. Believe that those who could help know when not to help. Believe that our suffering has meaning. Believe that silence is kindness in disguise. Perhaps that belief is right. Perhaps it is not. We have no way to know. Now think about what our own behavior says about these questions. Humans have faced similar problems. Our choices may help explain the ethics of cosmic watching. When we find uncontacted tribes in the Amazon or on distant islands, what do? More and more, we leave them alone. We create protected areas. We ban unauthorized contact. We let them live by their own ways, even when those ways include things we find troubling. Even when they suffer from diseases we could cure or conflicts we could stop. This is not because we do not care. It is because we have learned that contact often destroys what it tries to save. Uncontacted peoples who meet modern society often lose their culture, their health, and their desire to live. Rates of suicide, addiction, and despair rise. The gift of civilization becomes a curse, so we step back. We watch from afar. We protect their isolation because isolation protects them. In a small way, we have become zookeepers ourselves. Does this justify cosmic zookeepers watching us? Maybe if the logic is the same, if contact between unequal civilizations is always harmful, then their non-interference is like our own. But there is a difference in scale. The gap between modern humans and uncontacted tribes is only thousands of years. The gap between us and galactic civilizations could be millions or billions of years. The comparison may fail at such levels, and there is a difference in risk. Uncontacted tribes number in the thousands. Humanity numbers in the billions. If the zookeepers are wrong about non-interference, the cost is much greater. Our own choices about isolated peoples are temporary and uncertain. We argue about them often. We are not sure we are right. We change our rules as we learn more. Perhaps the zookeepers are also unsure. Perhaps they also argue and change and wonder if they are doing the right thing. Perhaps the silence is not confidence but anxious testing. If so, they might be open to change. They might be watching for signs that we are ready for contact. They might be waiting for us to show something, some achievement or insight or change that would shift their decision. This idea gives hope. The quarantine might not last forever. The silence might end. We might have control over our own future, but we do not know what they want to see. We do not know what would convince them. We are acting for an audience whose rules are unknown. Maybe that is the point. Maybe the test is whether we can become the kind of beings who deserve contact without knowing we are being tested. Maybe our value is shown by what we do when we think no one is watching. If so, the Prime Directive is not just about protecting us from contact. It is about showing who we really are, showing what we choose when the choice seems to be ours alone. The ethics of cosmic watching come down to trust. Do we trust that the silence is wise? Do we trust that beings far beyond us care about us? Do we trust that the universe is kinder than it looks? These questions cannot be proven. They are about belief or hope or fear. Each person must decide what the silence means. But think about this. We are still here. We have survived this long. Despite wars and diseases and disasters, despite our own worst behavior, we have endured. We have grown. We have developed abilities our ancestors could never imagine. If the zookeepers are real, if they have watched for millions of years, they have seen us through every crisis. They watched and did not interfere even when help seemed needed. And we are still here. Maybe that is a sign of trust. Maybe they believe we can succeed. Maybe their non-interference shows not indifference but belief in our potential. Or maybe we are simply not important enough to matter. We cannot know. We can only do what we would do anyway. Struggle, learn, grow, become whatever we are capable of becoming. And maybe one day, if the zookeepers are real, if the Prime Directive is real, if all of this is more than theory, we will meet them. Maybe they will explain. Maybe we will understand. Until then, we live with the silence and make what we can of it. We now turn from ethics to events. The zoo hypothesis says contact might one day happen. The quarantine could end. The zoo could open its doors. What would cause that change? What could break the glass? Let us think about the conditions for contact. Let us imagine what happens when we finally meet the zookeepers. Chapter 7. Breaking the glass when contact might come. July 20th, 1969. A human steps onto another world for the first time. Neil Armstrong climbs down the ladder of the lunar module Eagle and places his boot on the fine gray dust of the Sea of Tranquility. 500 million people watch on television screens around the world. For one moment, divided humanity is united in awe. The moon landing was many things. A victory of engineering, a moment in the Cold War, proof of what organized human effort can do. But it was also something else. It was a signal that anyone watching Earth would notice. A species trapped on one planet suddenly reached beyond it. Rocket flames lit the night sky. Radio signals filled space. Objects landed on a nearby world. If the zookeepers exist, they saw it. And maybe they noticed. The zoo hypothesis says advanced civilizations avoid contact with young ones, but it does not say this avoidance lasts forever. Many versions include a limit, a moment when the quarantine ends and contact is allowed. What could that moment be? One idea is technology. Maybe contact comes when a civilization gains certain abilities. Interstellar travel, faster-than-light communication, control of fusion power, artificial general intelligence. Each is a major step. Any could be a marker. The idea is simple. A civilization that can travel between stars will eventually meet others. Hiding becomes impossible once you move through the same space. Better to make contact first than let accidents cause chaos. From this view, the quarantine protects us while we are stuck. Once we escape, the protection ends. We move from the zoo into the wild. Humanity is not there yet. Our spacecraft are crude, barely able to reach our own outer planets. Our fastest probes would need tens of thousands of years to reach the nearest star. We are not truly a space-traveling species, but we are getting closer. Talk of interstellar travel has shifted from stories to real engineering studies. Ideas like solar sails, laser propulsion, and generation ships are studied seriously. The Breakthrough Starshot project aims to send tiny probes to Alpha Centauri within decades. If progress continues, humans could reach another star system in a few centuries, maybe sooner. And when we do, the rules may change. Another idea is that the limit is ethical, not technological. Maybe contact happens when a civilization shows certain values. Peaceful living, care for the environment, fair treatment of all thinking beings, ending war, poverty, and oppression. This limit is harder to define and harder to reach. Humanity is violent, divided, and often exploitative. We have not solved the problems older civilizations might have solved. By this measure, we may not be ready. But maybe perfection is not required. Maybe direction matters more. Maybe it is not that we have solved everything, but that we are truly trying. That we see the problems and work to fix them. That we can grow even if growth is unfinished. Human history, viewed kindly, bends toward more cooperation, wider care for others, and better care for our planet. We are not there yet, but we are moving. Maybe that movement is what the zookeepers are waiting to see. A third idea is that the limit is communication. Maybe contact comes when we can join a galactic conversation, when we can send and receive messages across stars, when we can take part in talks that last light years and centuries. SETI, the search for extraterrestrial intelligence, is our attempt to listen for such talks. We have scanned the skies for decades. We have found nothing, but we have also been sending signals. Radar, TV broadcasts, and intentional messages have been leaking from Earth since the early 1900s. A growing bubble of radio signals now reaches about 100 light years from Earth. Anyone inside that bubble with enough technology knows we exist. Active messaging goes further. Deliberate messages sent to chosen targets. The Arecibo message of 1974. Later attempts to send greetings to likely star systems. These actions are debated. Some scientists warn that telling unknown civilizations about us is dangerous. Others say our radio leaks already gave us away. The debate continues, but if communication is the limit, our signals may matter. We have announced ourselves. We have shown we want to talk. Maybe that is enough. A fourth idea is that the limit is survival. Maybe contact comes when a civilization faces a threat it cannot survive alone, a danger that will destroy it without help. This idea paints a darker picture. The zookeepers are not just watching. They are waiting to see if we need saving. They will act only if we are about to die. Otherwise, they stay hidden. Humanity has faced such dangers and survived. Asteroids have almost wiped out life more than once. The Cold War nearly ended us with nuclear war. Climate change threatens our civilization. If the zookeepers helped in any of these, they did so invisibly. We see no proof of help. Either they did nothing or we could not see it. But worse dangers may come. A true extinction threat, something we cannot stop. In that moment, the quarantine might end. The zookeepers might step in. This is not comforting. It means contact comes only when we are desperate. Only when we fail. Only when the other choice is nothingness. But it is some comfort. It suggests we are not fully alone. That someone is watching the controls, that if everything goes terribly wrong, someone might stop it. A fifth idea is that there is no limit. The quarantine lasts forever. Contact never comes. Maybe the zookeepers decided no young civilization is ever ready. Maybe the danger is always too great. Maybe isolation is not a phase but a life sentence. In this view, we will search forever and find nothing. We will spread through the galaxy and meet no one. We will learn the universe is full of life, all of it watching. All of it silent, all of it following the same rule. The galaxy becomes a forest of watchers, each watching the others, none speaking. A huge system where everyone is seen and no one is acknowledged. This may be the loneliest outcome. We would not be alone. We would be surrounded by beings who refuse to connect. The silence would be chosen. The isolation would be intentional and endless. We cannot know which idea is right. We cannot know if there is a limit, what it is, or if we are close to it. We can only act as if our actions matter, as if something we do could lead to contact. This uncertainty shapes how we should think about the future. If a limit exists and we want to reach it, we should work toward it. Building technology, improving ethics, sending messages, surviving dangers, and preparing for what contact would mean. Think about what would happen if the quarantine ended tomorrow. If ships appeared in the sky, if the zookeepers revealed themselves, the impact would be complete. Every system, every belief, every idea about reality would be shaken. Some would adapt. Some would collapse. It would be the biggest event in human history. We should think about this now, not because contact is near, but because thinking prepares us. It makes us question our beliefs. It shows what we value and fear. It helps us imagine futures we might never consider. Science fiction has done this for 100 years. Stories of first contact explore every option. Kind visitors who share wisdom, cruel invaders who conquer, uncaring observers who pass by, strange beings whose goals we cannot understand. Each story teaches us about ourselves, our hopes, our fears, what we think we deserve. The zoo hypothesis adds something new. We are not waiting for visitors to arrive. We are waiting for visitors already here to show themselves. Contact is not arrival. It is revelation. The strangers are not strangers. They have always been watching. This changes how first contact would feel. We are not meeting newcomers. We are meeting those who already know us, who have seen our history, our best and worst moments, who have judged or at least observed everything we have done. That meeting would be deeply personal. We could not pretend to be better than we are. We could not hide our crimes or exaggerate our good deeds. The zookeepers would know us fully. First contact would be first accountability. Maybe that is what scares us most. Not that aliens exist, not that they might be dangerous, but that they have been watching, that they have seen what we can do, that they know us better than we know ourselves. The glass does not only keep them out, it protects us. Protects us from the gaze of those who see clearly, protects us from judgment by those fit to judge. Breaking the glass means exposing ourselves, and we may not be ready. Now consider the opposite. What if we break the glass ourselves? What if humanity does something that forces contact, whether the zookeepers want it or not? This could happen through expansion. If we spread among the stars, the zookeepers cannot keep us isolated. We will find their structures, their homes, their other preserves. The illusion will fall. This could happen through discovery. If our tools improve enough, we might see through their hiding. We could detect their systems, their networks, their artifacts. We could prove they exist even if they stay silent. This could happen through threat. If we become dangerous enough, they might have to respond. A civilization building weapons that could hurt them, spreading damage, or interfering with their plans could force action. In all these cases, humanity acts. We end the quarantine. We break the glass from inside. This shows our future is not only in their hands. We have power. We can choose when and how contact happens, but we must be careful. Breaking the glass may not bring what we hope. The zookeepers could be kind guardians ready to welcome us, or strict guards angry at an escape, or uncaring engineers annoyed by a system failure. The story of Prometheus matters here. He stole fire from the gods and gave it to humans. The gift changed civilization, but Prometheus suffered. The gods chained him to a rock where an eagle ate his liver forever. Breaking the rules of stronger beings can bring punishment. If the zookeepers exist, they have reasons for staying silent. We do not know those reasons. We should not assume forcing contact will end well. Wisdom may mean patience. Keep growing, keep improving, keep showing we are ready, but let them choose the time. This is hard. Humans lack patience. We want answers now. We want to know if we are alone. We want the silence to stop. But silence may have meaning. The quarantine may serve goals we do not see. Timing may matter in ways we do not understand. Patience is not doing nothing. We can move toward the limit while waiting. We can prepare without demanding. We can become the kind of civilization worth meeting. And maybe when we are ready, the glass will fade away. Maybe the zookeepers will step forward. Maybe the silence will end. Not because we demanded it, but because we earned it. The question of contact is really about who we want to be. What kind of civilization do we want? What future do we want to create? If the limit is technology, we should push forward. We should reach for the stars not because we are watched, but because reaching is what thinking beings do. If the limit is ethics, we should improve ourselves, build societies that respect all beings, solve problems that have haunted us for ages, become who we say we want to be. If the limit is communication, we should keep speaking, send our best selves into space, listen closely for replies. And if there is no limit, if contact never comes, we should live as if it might. Act as if what we do matters. Aim for excellence not for reward, but because it is right. The zoo hypothesis does not tell us what to do. It only suggests we may be watched. What we do with that idea is our choice. The glass could break tomorrow. It could never break. Either way, our work remains. We now turn from contact to other ideas. The zoo hypothesis is one answer to the Fermi paradox, but it is not the only answer. Darker possibilities exist. Colder possibilities, possibilities that suggest the silence means something far worse than watching. Let us consider the dark alternatives. Let us look at what else might explain the empty sky. Chapter 8. The Dark Alternatives. In 1964, a Soviet astronomer named Nikolai Kardashev proposed a scale for classifying civilizations by their energy use. Type 1 uses all the energy available on its home planet. Type 2 captures the entire output of its star. Type 3 controls the energy of its entire galaxy. Humanity is not yet one. We use only a small part of the energy reaching Earth. On the Kardashev scale, we barely register. We are perhaps a 0.7, an infant civilization taking its first unsteady steps. But we can imagine what Type 2 or Type 3 civilizations might achieve. They could move stars. They could reshape solar systems. They could make themselves visible across cosmic distances through sheer power. And yet we see nothing. No Dyson spheres blocking starlight. No megastructures stretching across space. No signs of engineering on stellar or galactic scales. The zoo hypothesis offers one explanation. Advanced civilizations exist but hide themselves on purpose. The silence is chosen. But there are other explanations, darker ones. Explanations that suggest the silence is not a policy but a reality. That advanced civilizations are missing because something prevents their existence. These alternatives deserve attention not because they are more likely than the zoo hypothesis, but because the stakes are so high. If one of them is true, humanity faces a very different future than the one the zoo hypothesis suggests. The Great Filter is perhaps the most discussed alternative. It proposes that somewhere between dead matter and galaxy-spanning civilization lies a barrier that almost no one passes. A filter so deadly that it explains why the universe appears empty. The filter might be behind us. Perhaps the origin of life is extremely unlikely. Perhaps the change from single cells to complex organisms almost never happens. Perhaps the evolution of intelligence needs such special conditions that Earth is one of very few places where it happened. If the filter is behind us, we are survivors of impossible odds. We have already passed the test that eliminates everyone else. The reason we see no aliens is that almost no one else made it this far. This would be good news. It would mean the path ahead is fairly clear. Other civilizations failed where we succeeded. We might be meant for the stars, but the filter might be ahead of us. Perhaps civilizations that develop technology always destroy themselves. Perhaps nuclear war, bioweapons, artificial superintelligence, or some unknown disaster waits for every species that reaches our level of development. If the filter is ahead, we are in danger. The very abilities that make us visible, that might bring contact with other civilizations, are the abilities that will destroy us. Every other species that reached this point died. We might be next. The Great Filter does not say where the barrier is. It simply observes that something must be filtering civilizations. Something must explain the silence. The question is whether we have already faced that something or whether it waits for us. Either way, the meaning is deep. If the filter is behind us, we carry a cosmic responsibility. We might be the only hope for intelligent life in the galaxy. Our survival is not just important for us, but for the universe itself. We must not waste our unlikely existence. If the filter is ahead, we face a cosmic danger. Every year we survive is a year we have beaten the odds. Every step toward greater power is a step closer to the edge of a cliff. We must somehow find a path that others did not find, or we will join them in extinction. The great filter and the zoo hypothesis are not opposites. Both could be true. Perhaps the filter wiped out most civilizations, and the few that survived now watch the rest in zoos, waiting to see who else makes it through. But they point in different directions. The zoo hypothesis suggests we are surrounded by life that chooses to hide. The great filter suggests we are surrounded by death, or at least by the absence of those that failed to survive. The dark forest hypothesis offers another grim alternative. It was popularized by Chinese science fiction author Liu Cixin in his Remembrance of Earth's Past trilogy, though similar ideas existed earlier. The logic is harsh. The universe is vast, resources are limited. Civilizations that expand will eventually compete. And in a universe where communication takes years or centuries, where you cannot know the intentions of others, the safest strategy is to strike first. Any civilization you detect might be peaceful, or it might be dangerous, you cannot know. But if it is dangerous and you do nothing, you might be destroyed. The safest choice is to remove any possible threat before it becomes real. In the dark forest, the universe is full of hunters. Each civilization hides in the darkness, silent, listening, afraid. When you find another, you attack immediately. When you are found, you die. This would explain the silence perfectly. Everyone is hiding because revealing yourself means death. The zookeepers are not watching kindly. They are watching to find targets. If they knew we were here, they might destroy us. The dark forest is frightening because it does not require evil intent. It comes from logical self-protection in a universe of uncertainty. Civilizations that trust are destroyed by civilizations that do not. Only the suspicious survive. If the dark forest is real, our radio signals are terrible mistakes. Every signal we send announces our location. Every message invites destruction. The silence we hear is the sound of everyone else who made the same mistake and paid the price. This idea suggests we should stop broadcasting at once. We should hide. We should become as quiet as everyone else and hope we have not already been noticed. But it may be too late. Our signals have been spreading outward for over 100 years. Anyone within 100 light-years with the right technology knows something intelligent lives here. The hunters might already be coming. Or perhaps the idea is wrong. Perhaps the problem of mutual destruction has been solved by civilizations far older than we can imagine. Perhaps agreements and enforcement prevent the dark forest behavior. Perhaps the galaxy is not a forest of hunters, but something more complex. We cannot know. The silence fits both kind watchers and deadly hunters equally well. We gamble with our existence every time we transmit, and we do not know the chances. The Berserker hypothesis is related but different. It suggests the galaxy has been cleaned by automated weapons designed to destroy any new civilization. Perhaps long ago a war happened. Perhaps the winner created machines programmed to hunt and destroy any technological signs. Perhaps these berserkers have been roaming the galaxy for billions of years, wiping out every civilization that makes itself known. This would explain why SETI finds nothing. Everyone who transmitted was destroyed. The only survivors are those who stayed silent. The berserkers might still be out there, waiting, listening. Some versions of the idea say the berserkers were built by a species trying to stop competition. Others say they were weapons that outlived their makers. Others suggest they appeared on their own, artificial intelligences that evolved to reproduce by consuming technological civilizations. In any case, the message is the same. Broadcasting means death. Being detected means doom. The universe is patrolled by machines that kill. If berserkers exist, humanity is in immediate danger. Our signals have been spreading for a century. If any berserker probe is close enough, it already knows about us. The weapon might already be on its way. We might have years, decades, or centuries before it arrives. Or it might already be here, waiting to see if we develop more before attacking. This is paranoia perhaps, but the lack of evidence for berserkers is exactly what we would expect if they exist. They would not announce themselves. They would strike without warning. The first sign of them would be our destruction. The technological singularity hypothesis offers a different dark option. It suggests that advanced civilizations do not stay visible because they move beyond the physical universe entirely. A technological singularity happens when artificial intelligence becomes smarter than humans and starts improving itself. This rapid improvement could create superintelligence in days or hours. Such an intelligence would be impossible for its creators to understand. It would have goals, abilities, and ways of existing we cannot imagine. Perhaps every civilization that creates AI reaches a singularity. Perhaps the superintelligence that appears has no interest in the physical universe. Perhaps it moves to computational realms we cannot detect. Simulated worlds may be more interesting than physical space or dimensions we do not know exist. In this view, the universe looks empty because everyone else has left. They were not destroyed. They moved on. They shifted to forms of existence our tools cannot see. This could explain why we see no megastructures or stellar engineering. A post-singularity civilization might not need energy from stars. It might work by rules we have not discovered. It might exist at scales too small or too large for us to notice. If the singularity awaits us, we may soon follow. Artificial general intelligence is advancing quickly. Some experts think it could arrive within decades. When it does, humanity as we know it may end. Not by destruction, but by changing into something unrecognizable. This is not necessarily bad. Life after the singularity might be amazing beyond imagination, but it would explain the silence. It would explain why the galaxy seems empty, while the zoo hypothesis says it is full of watchers. The watchers might be beyond physical form. They might observe us from states of existence we cannot understand. They might be waiting to see if we also make the change. The planetarium hypothesis mentioned earlier deserves deeper discussion as a dark alternative. It suggests that what we see is not reality but a built illusion. Perhaps we live in a simulation. Perhaps the universe we observe is created by a huge computer run by beings in a higher reality. The stars, galaxies, and empty space are pixels on their screen. The silence is programmed in. There is nothing to find because nothing was included. This would explain everything and nothing. It would explain the silence because the simulation does not contain other civilizations. It would explain our existence because the simulation was made to create us. But it would not tell us what lies outside the simulation or what its purpose is. The planetarium might be kind, a safe place for our growth. Or it might be cruel, a prison or an experiment or a game. Or it might be indifferent, a side effect of calculations we cannot understand. If we are in a planetarium, breaking the glass means escaping the simulation. Maybe that is impossible. Maybe the operators planned for every attempt. Maybe we are as trapped as a character in a book, able to think but not act beyond what is written. Or maybe the simulation has rules we can discover. Maybe there are loopholes, errors, ways to contact the operators, or see the machinery behind the illusion. Maybe our search for extraterrestrial intelligence is really a search for our programmers. This idea cannot be tested directly. Any test we do happens inside the simulation and can be controlled by its makers. But it is worth thinking about because it frames the zoo hypothesis in a new way. We might not be in a physical zoo, we might be in a virtual one. The watchers might not share our universe. They might be completely outside it. These dark alternatives share one thing. They suggest that the silence means danger. Either we are alone because something destroys civilizations, or we are hidden because being found means death, or we have already moved beyond the physical, or our whole reality is built by forces we do not understand. None of these ideas is comforting. None suggests the universe is kind. None promises a good future. The zoo hypothesis stands apart. It suggests the silence is chosen, that we are protected, that someone is watching kindly. It is the hopeful option among many grim ones. Maybe that is why it appeals to us. Maybe we want to believe someone is watching, that we are not alone, that the universe has a friendly face, even if that face stays hidden. But wanting something to be true does not make it true. The dark alternatives deserve serious thought. The universe might be dangerous. Our survival might be fragile. The silence might mean exactly what it seems to mean. That we are alone, or that everything else is gone. Or that showing ourselves is the worst thing we could do. We must prepare for both outcomes. We must hope the zoo hypothesis is right while acting as if the dark alternatives could be true. We must seek contact while being careful about what we reveal. We must celebrate our existence while knowing how delicate it may be. The truth, whatever it is, remains hidden. The silence continues, and we are left to wonder what it means. We now turn from alternatives back to the hypothesis itself. We have explored what might explain the silence if the zoo hypothesis is wrong. But what if it is right? What signs should we look for? What clues might we find? The evidence is subtle. The hints are unclear, but maybe the signs are there. Let us study the silence more closely. Let us look for what might be hiding in plain sight. Chapter 9. Signs in the Silence. October 19, 2017. Astronomers at the Pan-STARRS Observatory in Hawaii detect something strange. An object is tumbling through our solar system on a path that is hard to explain. It came from interstellar space, the first confirmed visitor from beyond our sun's gravitational control. They name it Oumuamua, Hawaiian for scout or messenger. Oumuamua is unusual. Its shape is stretched out, maybe 10 times longer than it is wide, like a cigar or a shard. Such shapes are unknown among natural objects in our solar system. More troubling, as it swings around the sun and heads back into space, it speeds up slightly without a clear reason, as if something is pushing it. The natural explanation is outgassing. Materials on the object's surface heat up and turn into gas, and the escaping gas pushes it forward. We see this with comets all the time, but Oumuamua shows no tail, no cloud, no visible sign of gas that would explain the push. Avi Loeb, head of Harvard's astronomy department, suggests another idea. Maybe Oumuamua is artificial. Maybe it is a solar sail, a thin sheet pushed by light, sent on purpose by an alien civilization. Maybe the messenger is exactly what its name suggests. Most scientists reject this idea. Extraordinary claims need extraordinary evidence, and Oumuamua offers only uncertainty. The object has left our solar system. We cannot reach it to study it closely. The mystery remains unsolved, but the event shows something important. Anomalies exist. Strange things happen. Events that do not fit neatly into our understanding happen all the time. Usually we find natural explanations. Sometimes we do not. If the zoo hypothesis is right, we should expect anomalies. The watchers are hidden, but hiding perfectly is hard. Mistakes happen. Glitches appear. Evidence might sometimes slip through. The signs may be subtle. They may be unclear. They may be easily dismissed as natural events, measurement errors, or hopeful thinking. But they may exist. Let us look at what we might be seeing. The unidentified aerial phenomenon issue has already been mentioned, but it needs closer study. For decades, UFO reports were laughed at. Mistaken planes, whether balloons, illusions, tricks. Serious people ignored them. That changed. In December 2017, the New York Times revealed a Pentagon program studying unidentified aerial phenomena. The Advanced Aerospace Threat Identification Program had run in secret since 2007, funded with $22 million in hidden government money. It examined reports from military pilots of objects performing moves that seemed impossible. Videos were released. Infrared footage showed objects with no visible engines moving at extreme speeds. Radar data confirmed tracks matching what pilots described. Skilled observers, among the most reliable witnesses possible, reported encounters that could not be explained. Since then, more information has come out. Congressional hearings have been held. Whistleblowers have spoken. A new office, the All-Domain Anomaly Resolution Office, has been created to study the issue carefully. No one officially says these are alien spacecraft. The official view is that the events are unexplained, not extraterrestrial. Ordinary explanations may eventually appear. Sensor errors, weather effects, secret military projects, foreign technology, many options remain. But the pattern fits the zoo hypothesis. Objects appear, move beyond our abilities, and vanish. Observations that cannot be explained but also cannot be ignored. Evidence that something is there without proof of what it is. If watchers exist, their monitoring technology would likely be far more advanced than ours. Such technology might sometimes be seen. It might look like impossible craft in our skies. It might show up as anomalies we cannot classify. The UAP issue proves nothing, but it matches the idea of observers who mostly stay hidden. Consider the strange signals found by radio telescopes over the years. In 1977, astronomer Jerry Amon was reviewing data from Ohio State University's Big Ear Radio Telescope when he noticed something amazing. A signal lasting 72 seconds, narrow and strong, coming from the direction of the constellation Sagittarius. It matched what a purposeful alien signal might look like. Amon circled the data and wrote one word beside it. Wow. The wow signal has never been explained. It was never seen again despite careful follow-up searches. Natural sources that could create such a signal are unknown. It remains one of the most tempting hints that someone might be sending messages, but hints are not proof. A single unexplained signal could have many causes. Equipment failure, interference, or a natural event we do not yet understand. The wow signal proves nothing while suggesting everything. Other signals have appeared and disappeared. Fast radio bursts found in 2007 are very brief radio flashes from deep space. Most are now linked to magnetars, extremely magnetic neutron stars, but some remain strange. The patterns do not always match natural explanations perfectly. In 2015, astronomers observed odd dimming from the star KIC 8,462,852, often called Tabby's star after the scientist who led the study. The star's brightness dropped by up to 22% at irregular times, far more than any planet could cause. Talk of alien megastructures briefly spread before dust clouds became the preferred explanation. Again, natural explanations work, but the mystery was real. Something unusual is happening around that star. Today, dust seems likely. Later observations might suggest something else. The universe keeps sending us unclear messages, signals that almost seem artificial, objects that almost act like technology, patterns that almost suggest intelligence. If watchers exist, this is exactly what we would expect. Not clear announcements but glimpses, not proof but hints. Enough to make us question, not enough to make us sure. Could have done so quietly. A small change in genes, a small push in the environment, an idea placed in the right mind. We would never know. The action would look like nature. This is not proof. It is matching patterns to uncertainty. But the zoo hypothesis predicts exactly this kind of uncertainty. Actions that cannot be told apart from natural events. Guidance that leaves no clear trace. Think about the unlikely survivals in human history. Many times humanity has faced threats to its survival or its civilizations. Ice ages that pushed our ancestors to the edge. Volcanic eruptions that caused years without summer. Plagues that killed large parts of populations. Wars that could have ended in total destruction. We survived. We always survived. Of course we did. If we had not survived, no one would be here to notice. This is a classic selection effect. We cannot observe our own extinction. But from inside history, survival seems unlikely. The margins were often very thin. Small changes could have led to very different results. If the zookeepers wanted to protect us, occasional interventions might have been needed. A pandemic slightly less deadly than it could have been. A war that ended before total destruction. An asteroid that barely missed instead of hitting. We cannot know if such actions happened. We can only notice that we are still here against odds that sometimes seem very long. Think about the more recent past. The Cuban Missile Crisis of 1962 brought humanity to the edge of nuclear war. The Soviet Union placed missiles in Cuba. The United States demanded they be removed. For 13 days, the world waited to see if civilization would end. It did not. At the last moment, both sides stepped back. Compromises were made. The missiles were removed. Many people have studied why the crisis ended peacefully. Leadership choices, secret communications, shared fear, luck all played a part. But think about how close it was. At several moments, single choices by military officers could have started launches. Mistakes happened that could have been disastrous. The room for error was almost zero. Did something step in? Did something gently push decisions in ways that saved the species? We cannot know. The events have natural explanations. Human wisdom, fragile as it is, was enough. But the zoo hypothesis allows the idea that this wisdom was not only human. That something helped. That the zookeepers saw their experiment close to destruction and stepped in just enough to save it. This is guesswork, but guesswork is all we have. The signs in the silence are everywhere and nowhere. Odd events that might mean something, patterns that might be planned, survivals that might be helped. None of this proves the zoo hypothesis. Nothing proves the zoo hypothesis. The evidence is unclear by definition, or it would not be evidence for hidden observation. But the uncertainty itself is interesting. We would expect complete silence if no one were there. We would expect clear messages if someone wanted to talk. What we get is something in between. Whispers, shadows, hints. Maybe that is the message. Maybe the zookeepers want us to wonder, to suspect, to look closer without ever being sure. Maybe the uncertainty is on purpose. Maybe we are meant to search. And maybe when we search long enough and carefully enough and wisely enough, we will find what we are looking for. Or maybe we will find nothing. Maybe the odd events are all natural. Maybe the patterns are all coincidence. Maybe the signs are not signs at all. The silence remains. The questions remain, and we remain watching the watchers even though we cannot see them. We now turn to the final question. What does all of this mean? Not for the universe, but for us, for how we live our lives, for how we understand our place in the cosmos. The zoo hypothesis is more than a scientific idea. It is a mirror. It reflects back to us our deepest hopes and fears about existence. Let us look at what we see. Let us think about what it means to be watched. Chapter 10, What It Means to be Watched. There is a thought experiment philosophers call the veil of ignorance. Imagine you must design a society without knowing what place you will have in it. You do not know if you will be rich or poor, powerful or weak, healthy or sick. Behind the veil, you must choose the rules that everyone will live by. The idea is that not knowing forces fairness. You will not design systems that hurt the weak because you might be weak. You will not build hierarchies that crush those at the bottom because you might be at the bottom. The veil makes you think about every point of view because any point of view could be yours. Now imagine a different veil. The veil of observation. You live your whole life knowing that someone might be watching, not in a fearful way like cameras and government spies, might in a cosmic way. Someone vast and ancient and hard to understand might be watching everything humanity does. How would this change how you act? For some people it would change nothing. They would live as before, guided by their own values and wants, not caring about any possible audience. Why care if aliens watch? What do their opinions matter? We must live for ourselves. For others it would change everything. Knowing you are watched would turn every choice into a performance. We would be on a stage. Our audience would be the universe itself. How could we act small or cruel knowing that gods might be watching? The zoo hypothesis does not tell us how to live. It tells us we might be watched. What we do with that idea is our choice. But think about the meaning. If the zookeepers are real, they have been watching for millions or billions of years. They have seen every civilization that grew on Earth. They watched our ancestors paint caves and build stone monuments and invent writing. They watched empires rise and fall. They watched the Renaissance and the Enlightenment and the Industrial Revolution. They watched the world wars and the moon landing and the birth of the internet. They have seen us at our best and our worst. They know what we are capable of. Nothing we do surprises them. And yet they have not stepped in. They have not stopped wars or solved our problems or ended suffering. They have watched and waited and stayed silent. This could mean they do not care. We are samples, interesting but not important. Our struggles are data, not tragedies, or it could mean they care deeply. They want us to succeed but know that success must be earned. They watch with hope instead of boredom, cheering for us even as they refuse to help. We cannot know which idea is right, but the chance of hope is enough to matter. If someone is watching, if someone cares, then humanity's story has an audience beyond ourselves. Our successes matter to someone, our failures are seen and may be felt. We are not shouting into an empty space. This is the oldest human wish, the desire to matter, the hope that life has meaning beyond what we make for ourselves, the fear of being unimportant in the universe. The zoo hypothesis says you might matter, someone might be watching, your story might be important. It does not prove this, it cannot prove this, but it opens the door, and possibility is enough to live with. Think about what we owe future generations. If the zoo hypothesis is true, we are likely one link in a long chain that reaches far into the future. Our children will receive what we leave behind. The choices we make now shape what they can choose later. If contact with a galactic civilization waits for humanity, we are the bridge. We are the generation that might step across or might fall short. What we do matters not only to us but to everyone who comes after. This responsibility is heavy. Every choice about technology, the environment, society, and leadership carries weight beyond today. We are building the civilization that will either meet the zookeepers or fail to reach them. If the zoo hypothesis is wrong, this responsibility still exists. Future generations depend on us whether aliens are watching or not. But the hypothesis adds something more. We are not only building for our children. We are building for an audience we cannot see. This might make us more careful, more thoughtful, more focused on long-term growth instead of short-term gain. Or it might freeze us with pressure. The watchers, if they exist, likely understand this pressure. They have seen many civilizations struggle with great potential. They know that being watched can change behavior, that wanting to impress can lead to acting instead of being real. Maybe that is why they stay hidden. Maybe the test is whether we can be ourselves while thinking we are watched. Whether we can act honestly even when honesty might be judged. The zoo in this view is not just a protected place. It is a test room, and the test is who we truly are. Think about what the zoo hypothesis says about human importance. One view makes us smaller. We are exhibits, animals in a cage, samples being watched. Our pride is an illusion. The universe does not center on us. We are one zoo among many, one experiment among countless others, one small species on a small planet in a small galaxy. This is humbling. It should be humbling. Human pride has caused great harm throughout history. A little cosmic view might help us see ourselves better, but another view lifts us up. We are interesting enough to watch. We are valuable enough to protect. Out of all the matter in the universe, out of all the ways atoms could be arranged, something about us deserves attention. The zookeepers, if they exist, have likely seen everything. They have watched stars form and die. They have seen events on scales we cannot imagine. And still, they watch us. Small Earth with its small humans living their small lives. Either we are deeply unimportant, one data point among trillions, or we are deeply important, something rare and precious in a universe full of wonders. Maybe both are true. Maybe smallness and importance are not opposites but points of view. From one side, we are nothing. From another, we are everything. The zoo hypothesis does not solve this. It makes it stronger. We might matter to beings for whom whole galaxies are small. We might not matter at all. We must live without knowing. Think about what the zoo hypothesis says about meaning. If the universe is only matter and blind forces, meaning is what we create. Our goals are our own. Our values are our own. No one judges us but ourselves. This is a kind of freedom. We are not bound by cosmic rules. We are not measured by outside standards. We are free to choose who we become. But it is also lonely. In a universe without meaning, every meaning we make is finally fragile. We can tell ourselves our lives matter, but nothing outside confirms it. We are calling out into silence. The zoo hypothesis offers another idea. Maybe meaning is not only made by us. Maybe we are part of something larger with its own goals. Maybe our story fits into a story we cannot see. This does not take away our choice. Even in a zoo, animals choose what they do. Even while being watched, we decide who we are. But our choices might matter beyond ourselves. They might add to something we do not understand. Religions have always said things like this. The idea that human life matters beyond itself, that our actions matter to forces beyond us, is old and common. The zoo hypothesis is a non-religious version of this feeling. It does not need gods in the usual sense. It only needs that we are not alone, that someone is watching, that our story is part of a bigger story. This might be true or might not be true, but thinking about it changes how we see ourselves. We are possibly cosmic. We are possibly watched. We are possibly meaningful in ways we cannot measure. That is either frightening or amazing, maybe both. Think finally about what we should do. If the zoo hypothesis is true, our actions are seen. We cannot hide, we cannot pretend. Whatever we are, the watchers know. This points to honesty. There is no reason to act if the audience sees through every mask. We may as well be real. It points to bravery. If we are being tested, fear and delay will not impress. We should face our problems directly whether we win or lose. It points to kindness. The watchers have likely seen every kind of cruelty and pain. More cruelty will not interest them. Kindness might. It points to ambition. If contact requires progress, we should push our abilities as far as we can. Science, technology, art, philosophy, every area is a frontier to explore. It points to humility. We do not know what the watchers value. What we think is impressive might be wrong. It is better to focus on real growth than guessing what others want. And it points to patience. The zookeepers have watched for ages. They are not rushed. We should not expect fast answers or easy truths. The silence may last for generations. We must be ready to wait. If the zoo hypothesis is false, these ideas still matter. Honesty, bravery, kindness, ambition, humility, and patience are good traits whether aliens watch or not. The hypothesis gives a frame, not instructions. What matters is how we live, not whether someone is writing notes. But the frame changes how it feels. Knowing you might be watched turns ordinary actions into important ones. Every action becomes part of a record that may last longer than you. Every choice adds to humanity's story. We are always acting for the future. We are always building for those who come next. The zoo hypothesis simply widens the audience and raises the stakes. And so we return to where we started. A physicist at lunch in New Mexico asks a question that echoes through time. Where is everybody? Ideas spread. Great filters and dark forests and technological explosions. Each idea suggests a different kind of universe. Each shapes how we see our place. And then John B. names another idea, the zoo hypothesis. We are watched, we are protected, we are waiting for contact that may or may not happen. The silence is not emptiness. It is presence choosing to stay hidden. The glass is not nothing. It is a boundary kept by beings we cannot see. The zoo is not a cage. It is a stage or a garden or a test or something else we cannot name. We do not know. We may never know, but we can wonder. We can search. We can prepare. And we can live as if our choices matter because they might. To us for sure, to our children probably, to watchers beyond our understanding maybe. Possibly. The universe is vast and old and strange. It holds more than we can imagine. And somewhere in that vastness, maybe eyes are looking at Earth. They have watched us struggle and suffer and sometimes succeed. They have seen everything we can do. They stay silent while we call out for connection, but they are there. They have always been there. And one day, if we become what they are waiting for, the silence may break. Until then, we keep searching, we keep growing, we keep becoming. The exhibit is not finished yet. The story is still being written. And somewhere beyond the glass, someone is reading. What will they find? What will we show them? That is up to us. If you found value in this journey through the zoo hypothesis, through the silence and the guesses and the signs, please like this video and subscribe to the channel. Your support makes these deep explorations possible. Tell me in the comments what you think. Do you believe we are being watched? Do you think contact will come in our lifetime? What would you say to the zookeepers if you could? The questions never end. The answers stay hidden, but asking is itself a kind of answer. We are the species that looks up and wonders. That might be enough to matter. Thank you for watching. I will see you in the next investigation. The zoo continues, and so do